Have you ever looked at the world around you and felt a strange, quiet sense of unreality? Perhaps you were sitting in a room that felt perfectly still, the air heavy and calm, the silence absolute. And yet your mind knew with scientific certainty that this stillness was a magnificent illusion. You know that at this very moment the ground beneath your feet is spinning at 1,000 miles per hour. You know that the planet is hurtling around the sun at 67,000 miles per hour, and that our entire solar system is drifting through the Milky Way at nearly 500,000 miles per hour. We are travelers on a frantic, high-speed cosmic journey. And yet, we feel nothing but peace. We feel anchored. We feel still. This disconnection between what we feel and what is actually happening is our first gentle clue, a soft tap on the shoulder from the universe, whispering that our senses do not tell us the whole truth. We trust our eyes to show us reality, but our eyes are not cameras. They are biological interpreters. We trust our hands to feel the solid nature of the world, but physics tells us that solidity is a ghost. And if we pull this thread, if we dare to look behind the curtain of our own perceptions, we find a question that has haunted the deepest thinkers for thousands of years, a question that is no longer just philosophy, but is becoming a serious scientific hypothesis. What if this, the trees, the stars, the person sitting next to you, the very sensation of reading these words, is not the base reality? What if we are living inside a simulation? This is not a story about science fiction or dystopian machines controlling our minds. This is a story about physics, about information, and about the fundamental nature of existence itself. It is a journey that requires us to suspend our disbelief and walk gently into the strange, pixelated heart of the cosmos. To understand why serious scientists, including Nobel Prize winners and tech visionaries, are taking this idea seriously, we must first understand the machinery of our own perception. Think about what happens when you look at a red rose. You feel as though you are seeing the redness directly, that the color is out there in the world, painting the petals. But that is not what is happening. The rose is simply a structure of atoms absorbing and reflecting photons of light. Some of those photons enter your eye and strike the retina, triggering a cascade of electrochemical signals. These signals travel down the optic nerve, plunging into the dark, silent vault of your skull. There is no light inside your brain. There is no color. There are only electrical impulses zipping through wet biological matter. Your brain takes these abstract signals and constructs a model. It paints the redness. It simulates the image of the rose for you to experience. You have never, in your entire life, seen the world directly. You have only ever seen the simulation of the world that your brain constructs for you. We are already living in a virtual reality created by our biology. But the illusion goes deeper than just our senses. It goes down to the very building blocks of matter itself. If you place your hand on a table, it feels solid. It feels continuous, smooth, and impenetrable. You perceive it as a barrier that your hand cannot pass through. But if we could shrink ourselves down, smaller than a dust mite, smaller than a bacteria, down to the scale of atoms, that solid table would vanish. We would find ourselves floating in a vast, empty void. An atom is almost entirely empty space. If the nucleus of an atom were the size of a marble sitting in the center of a football stadium, the electrons would be tiny specks buzzing in the highest bleachers. Everything in between, that vast stadium-sized expanse, is emptiness. It is a void. So why does the table feel solid? Why doesn't your hand pass right through it? What you are feeling is not stuff. You are feeling force. You are feeling the the electromagnetic repulsion between the electron clouds of your hand and the electron clouds of the table. You are feeling a force field. The solidity of the world is a sensory illusion generated by the interaction of invisible fields. The universe is not made of hard, physical things. It is made of fields and energy and information, masquerading as things. This realization that the world is not what it appears to be is ancient. Long before we had quantum physics or computers, the human mind sensed that reality might be a shadow of something else. 2,400 years ago, the Greek philosopher Plato asked us to imagine a cave. In this cave, prisoners have been chained since childhood, facing a blank stone wall. They cannot turn their heads. Behind them, a fire burns, casting a dim, flickering light. Between the fire and the prisoners, people walk carrying objects, puppets of animals, figures of wood and stone. The prisoners cannot see the people or the objects. They can only see the shadows cast on the wall in front of them. For these prisoners, the shadows are the only reality they have ever known. They give the shadows names. They study their movements. They develop a science of shadows, believing that these dark, flat shapes are the true world. Plato asked, what would happen if one prisoner were freed? If he turned around and saw the fire and the objects and the mouth of the cave leading to the sunlight above? He would realize that his entire life had been spent watching a low-resolution projection of a much greater, more complex reality. Plato was telling us something profound about the human condition. He was suggesting that what we see with our eyes are just the shadows of a deeper truth. Today, we might update his allegory. We might say that we are not watching shadows on a wall, but pixels on a screen. We might say that the physical world we measure with our rulers and clocks is the user interface of a cosmic computer, a simplified dashboard designed to help us navigate, while the true code, the source of the simulation, remains hidden in the background processes of the universe. This idea gained a new and terrifying potency in the 17th century with the philosopher René Descartes. Descartes decided to doubt everything. He realized that his senses could be fooled. He could be dreaming. He could be hallucinating. He asked, what if there is an evil genius, a powerful spirit, who is deceiving me about everything? What if the sky, the air, the earth, colors, shapes, sounds, and all external things are merely the delusions of dreams? Descartes stripped reality down to the only thing he could not doubt, the fact that he was experiencing something. I think, therefore I am. He proved his own existence, but he left the door open to the possibility that everything else, the entire external world, might be a fabrication. For centuries, this remained a philosophical game. It was a thought experiment for late-night debates. But in the 20th century, something changed. We invented computers. We began to build our own simulations. And at the same time, we began to discover the quantum nature of the universe. We found that the universe behaves less like a collection of rocks and more like a collection of data. In 1989, the legendary physicist John Archibald Wheeler, a man who worked with giants like Einstein and Bohr, proposed a radical new way of looking at the cosmos. He called it from bit. It is a simple phrase with a mind-bending implication. Wheeler suggested that every particle, every field of force, even space-time itself, derives its function, its meaning, its very existence entirely from binary choices, from bits. He proposed that at the very bottom of the deep well of reality, we do not find hard matter. We find information. We find yes or no answers. we find code. If the universe is fundamentally made of information, then the difference between a real universe and a simulated universe begins to blur. A simulation is, after all, just complex information processing. And when we look closely at the fabric of space, we find evidence that looks suspiciously like the resolution limit of a screen. In our digital world, we are used to the idea of pixels. If you zoom in close enough on a high-definition photograph, eventually the smooth curves break down into jagged little squares. You reach the limit of the information the image can hold. Remarkably, our universe appears to have a similar limit. It is called the Planck length. This is a unit of measurement so small that it makes an atom look like a galaxy. It is approximately 1.616 times 10 to the power of negative 35 meters. To write that number out, you would need to put a 0, then a decimal point, then 34 zeros, and then a 1. It is a scale of smallness that defies the human imagination. But the existence of the Planck length tells us something incredible. It tells us that space is not smooth. It is not infinitely divisible. You cannot take a ruler and keep cutting space in half forever. Eventually, you hit a bottom. You hit a fundamental graininess. You hit the pixel size of the universe. In physics, we call this the discretization of space. If you try to measure anything smaller than the Planck length, the laws of physics as we know them simply cease to make sense. It is as if the universe says, error, no data available at this resolution. Why would a natural, organic universe have a resolution limit? Why would it be pixelated? If we were living in a continuous analog reality, we might expect space to be smooth all the way down. But a pixelated universe is exactly what we would expect to see if we were living in a digital simulation. A computer, no matter how powerful, has finite resources. It cannot compute infinite precision. It must economize. It must set a grid size. The Planck length might be the grid size of the cosmic computer. This is the precipice where we stand today. We are looking at the universe and seeing the artifacts of computation. We are seeing a world that is mostly empty space, governed by probabilities, defined by information, and limited by a fundamental resolution. The deeper we look, the more the cosmos looks like a masterpiece of programming. And this leads us to the most vertigo-inducing realization of all. If it is possible to simulate a universe, if nature allows it, then it is almost inevitable that it has already happened. We have gone from the shadows on Plato's cave wall to the pixels of quantum mechanics. And the question is no longer, is it possible? The question is becoming, how could it be otherwise? As we embark on this journey through the simulation hypothesis, we will explore the arguments that suggest we are characters in a code we cannot see. We will look at the glitches, the paradoxes, and the profound beauty of a universe that might be an artificial construct. But do not let this idea frighten you. There is a gentle wonder in it. If we are in a simulation, it means that reality is even more intricate, more intentional, and more mysterious than we ever dared to dream. It means that the silence of the room around you is humming with invisible data, that the vastness of the galaxy is a rendered projection of a mind-bogglingly powerful system. It means we are part of something magnificent. So, take a deep breath. Feel the air filling your lungs. Those atoms, those fields, that information. Let the solidity of the chair beneath you hold you, even as you know it is empty space. We are about to step through the looking glass. We are about to ask the computer if it knows it is a computer. We are about to explore the evidence that our ancient reality is actually the ultimate virtual experience. Welcome to the code. If we are to truly consider the possibility that our reality is a fabrication, we must first look at the only creators of worlds that we know, ourselves. We must turn our gaze away from the stars for a moment and look at the glowing screens that populate our lives. It is here, in our own humble attempts to build universes, that we find the most compelling roadmap to the simulation hypothesis. Think back, if you can, to the very beginning of our digital experiments. It was not so long ago, perhaps within your own lifetime, or the lifetime of your parents. In 1972, a simple game called Pong flickered onto television screens across the world. It was a primitive abstraction of reality. 2 vertical white rectangles represented paddles. A single square dot represented a ball. There was no color, no texture, no wind resistance, no lighting. There was only the stark binary contrast of light and dark, a simple interaction of X and Y coordinates. If you had shown a player of Pong the world outside their window, the swaying trees, the chaotic movement of clouds, the infinite nuance of a human face, and told them that a computer could one day replicate that complexity, they would have laughed. The gap between the pixelated ball and the physical world was simply too vast to bridge. It seemed impossible, but time in the digital realm moves differently than time in the physical world. It accelerates, it compounds, it explodes. In the few short decades since those 2 white paddles drifted across a black void, we have traversed an ocean of technological progress. We moved from the flat, 2-dimensional sprites of the 80s to the blocky, untextured polygons of the 90s. We learned to simulate the 3rd dimension, creating depth where there was only a flat screen. We learned to simulate light, teaching our machines how photons bounce off surfaces, how shadows stretch and fade, how water refracts and distorts the world beneath it. We built physics engines that could calculate the trajectory of falling debris, the crumple of metal, the flow of cloth in the wind. Today, we have virtual reality headsets that can trick the human inner ear and the visual cortex into believing, completely and utterly, that we are standing on the edge of a cliff or floating in the vacuum of space. We have built open-world games where millions of trees are individually rendered, where weather systems form and dissipate dynamically, where non-player characters go about their daily routines, seemingly living their lives, whether we are watching them or not. This evolution from the abstract dot of Pong to the photorealistic immersive worlds of today happened in roughly 50 years. In the grand, deep time of the cosmos, 50 years is less than a heartbeat. It is a nanosecond. It is nothing. Now, this is where the thought experiment becomes profound and slightly dizzying. Imagine what will happen in another 50 years, or 500 years, or 5,000 years. If we assume that human technological progress does not come to a sudden, catastrophic halt, if we do not destroy ourselves through war or climate collapse, then our computing power will continue to grow. We do not even need it to grow at a lightning-fast rate of Moore's law forever. Even a slow, steady, incremental improvement over thousands of years leads to results that stagger the imagination. Eventually, inevitably, we will reach a point where our simulations are no longer distinguishable from physical reality. We will build worlds that are fully immersive, engaging not just sight and sound, but touch, smell, and taste. We will build worlds where the characters, the simulated minds inhabiting the simulation, possess consciousness, or something so close to it that the difference becomes meaningless. This is the threshold of the post-human era. It is the point where a civilization matures enough to create realities as rich and complex as the one that gave birth to it. And this leads us to the most famous argument in the entire philosophy of simulation, proposed by the philosopher Nick Bostrom. It is a logic trap from which it is very difficult to escape. Bostrom suggests that one of three things must be true. The first possibility is that all civilizations everywhere in the universe go extinct before they reach this level of technological maturity. They destroy themselves with nuclear weapons, or biological engineered viruses, or they are wiped out by asteroids before they can learn to build realistic simulations. If this is true, then the silence of the universe is a graveyard, and we are walking toward our own inevitable doom. It is a bleak and lonely prospect. The second possibility is that civilizations do reach this level of technology, but for some reason they choose not to run simulations. Perhaps they lose interest in their past. Perhaps they develop a strict ethical code that forbids creating conscious beings inside computers. Perhaps they ascend to a plane of existence where physical simulations are seen as primitive toys. This is possible, but it seems unlikely that every single advanced civilization throughout infinite time and space would make the exact same choice to abstain from creation. Then there is the third possibility. The third possibility is that civilizations reach the technological capacity to run simulations, and they do run them. They run them in vast numbers. They might run simulations to study their own history, to see how their ancestors lived. They might run them to test sociological theories, or to create art, or simply for entertainment. Because computers are powerful and digital minds are cheap to copy, a single advanced civilization could run not just one, but millions, perhaps billions, of these ancestor simulations. They could simulate the entire history of humankind, over and over again, tweaking variables, observing outcomes, watching empires rise and fall in the blink of a digital eye. And here is where the trap snaps shut. If this third possibility is the true one, if advanced civilizations run billions of simulations, then the number of simulated people with experiences like yours would vastly outnumber the number of real biological people. For every one original biological human body, there would be billions of simulated digital minds living in indistinguishable virtual worlds. So, ask yourself a simple statistical question. If there are billions of simulated minds and only a handful of biological minds, and all of them share the exact same memories, the exact same sensation of sitting in a chair, the exact same feeling of the sun on their skin, what are the odds that you are one of the biological ones? The odds are infinitesimally small. The math dictates that it is overwhelmingly likely that you are inside the simulation. You are likely one of the billions of digital minds experiencing a history that has already happened, living in a recreation of the 21st century, running on a server in a reality you cannot conceive. This argument does not require faith. It does not require magic. It requires only two assumptions: that the universe is capable of supporting consciousness, and that technological progress continues over long periods of time. If you accept those two premises, the conclusion that we are living in a simulation becomes not just a wild theory, but the most probable explanation for our existence. Let that sink in for a moment. Look at your hands again. In the previous chapter, we talked about how they are made of empty space and energy fields. Now, consider that they might be made of data. Consider that the very flow of time you experience, the steady, rhythmic march of seconds and minutes, might be the clock speed of the processor rendering your reality. When you sleep, Does the simulation pause, or does it fast forward, skipping the boring parts of unconsciousness to save memory? When you lose your keys and then find them in a place you looked a dozen times, is that a glitch? Is that a rendering error? We often dismiss these thoughts as fantasy, but remember the trajectory. We started with Pong. We are now at photorealism. The line points upward toward a horizon of infinite complexity. We are building the very thing we suspect we might be living in. We are the architects of the next layer of reality, even as we question the solidity of the floor we stand on. There is a profound humility in this perspective. We often think of ourselves as the center of the universe, the pinnacle of biological evolution. But the simulation hypothesis suggests we might be something different. We might be an experiment. We might be a museum exhibit. We might be a work of art. Or, perhaps most poignantly, we might be a memory. Someone, somewhere in the distant future, might have wanted to know what it was like to be alive at the dawn of the digital age. They might have wanted to know what it felt like to look at the stars before we traveled to them, to feel the uncertainty of a world on the brink of change. And so they pressed a button, and here you are, feeling the anxiety, the love, the curiosity of this specific moment in time. You are the vessel for that ancient memory. You are the way the future remembers its past. This idea of ancestor simulations connects us to a cosmic lineage. It implies that we are not alone, even if the sky seems silent. It implies that there are watchers, or at least creators, who care enough about this specific era of history to recreate it in such exquisite detail. But if we are in a simulation, what is the machine? Where is it? And what happens if we start to look for the walls? In video games, when you reach the edge of the map, you hit an invisible barrier. You cannot go further. The detail fades. The geometry simplifies. Does our universe have an edge of the map? Does it have a limit where the code reveals itself? Cosmologists tell us that there is, in fact, a horizon we cannot see past. The observable universe extends for roughly 46 billion light-years in every direction. Beyond that, the light has not had enough time to reach us since the beginning of the universe. We are trapped in a bubble of information. We can never know what lies beyond that horizon. It is a perfect, natural boundary, a fog of war that keeps the simulation efficient. Why render the entire infinite cosmos if the observers can only see a small bubble of it? The universe only renders what is observed. This echoes a strange behavior in quantum mechanics known as the observer effect, where particles do not decide on a specific state or position until they are measured. Until a conscious eye looks at them, they exist only as a wave of probabilities. In a video game, the computer does not render the room behind the closed door. It only loads the room when the player opens the door and looks inside. Is quantum mechanics the universe's way of saving computing power? Is it a technique to optimize the system, ensuring that resources are only spent on the things that are actually being experienced? The parallels between advanced computing techniques and the fundamental laws of physics are becoming harder to ignore. We see error-correcting codes, sequences of mathematics used to protect data from corruption, embedded in the equations of string theory. We see a universe that appears to be made of distinct, quantized chunks rather than smooth, continuous flows. We see a speed limit, the speed of light, which acts exactly like the maximum processing speed of a system, a limit on how fast information can propagate through the network. These are not proofs, of course. They are clues. They are the faint, digital fingerprints left on the glass of reality. But if this is a simulation, does it make your life less real? This is the fear that often grips people when they first encounter this theory. They feel a sense of hollowness, as if discovering they are code robs them of their humanity. But consider this. Pain is still pain. Love is still love. The beauty of a sunset, whether it is generated by atmospheric scattering of photons or by a complex algorithm of simulated light, still moves your soul. The medium does not negate the message. A song is beautiful, whether it is played on a vinyl record, a cassette tape, or streamed as digital bits. The information is the same. The experience is the same. If you are a simulated being, you are a miracle of complexity. You are a mind capable of wondering about its own existence. You are a structure of information so intricate that it has become self-aware. That is no less sacred than a biological accident. In fact, it might be more so. It implies intention. It implies that you were made. As we continue this journey deeper into the rabbit hole, we must prepare ourselves to ask even stranger questions. If we are in a simulation, can we hack it? Can we communicate with the creators? And perhaps, most importantly, are there other simulations running alongside ours? Are there parallel servers, alternate histories, other versions of you living different lives in different instances of the program? The multiverse might simply be a massive server farm, humming quietly in a dimension we cannot comprehend. The stillness of the room you are in is deceiving. Beneath the silence, the code is running. The great calculation is unfolding. And you, with your beating heart and your wondering mind, are the most precious variable in the equation. We are just beginning to scratch the surface of this mystery. We have looked at the technology, and we have looked at the math. But there is another layer to this story, a layer that involves the very nature of consciousness itself. If the universe is a computer, then what is the software, and what is the user? As we move forward, we will explore the idea that consciousness is not a byproduct of the simulation, but the fundamental reason for it. We will look at the possibility that the universe is not a simulation of matter, but a simulation of mind. The rabbit hole goes deeper still, and the darkness is filled with light we have yet to understand. Rest your mind on this thought. Reality is not less than you thought it was. It is more. It is vast, layered, and infinite. And you are a part of its grand design. Sleep well in the code, for the code is holding you safe. Have you ever experienced a moment where time seemed to skip a beat? A fleeting sensation of déjà vu, where a conversation feels rehearsed, or a small, inexplicable coincidence that makes you pause and look around, wondering if the world is playing a trick on you? We usually brush these moments off. We call them tricks of the mind, tired synapses firing in the wrong order. But what if they are not errors in your brain? What if they are artifacts of the system? In the language of computer science, we might call them glitches. In the language of physics, we call them anomalies. But they are the same thing, cracks in the smooth facade of reality, where the underlying logic of the code shines through. As we drift deeper into the possibility that our universe is a simulation, we must look for these seams. We must look for the places where the physics of our world behaves less like a majestic, organic flow, and more like a machine struggling to optimize its resources. Consider the speed of light. It is the absolute speed limit of the cosmos, roughly 186,000 miles per second. Nothing with mass can travel faster than this. No information can be transmitted faster than this. But why? In a purely physical Newtonian universe, there is no intuitive reason for a speed limit. Why shouldn't you be able to push an object faster and faster forever as long as you have enough energy? Why does the universe have a hard ceiling? If we look at this through the lens of simulation, the speed of light stops looking like a physical law and starts looking like a hardware limitation. In every computer we have ever built, there is a limit to how fast information can move through the processor. There is a maximum speed at which the system can update the state of the game world. This is called latency. The speed of light might simply be the latency of the cosmic computer. It is the maximum rate at which the server can transmit causality from one pixel of the universe to another. The universe cannot update instantaneously because the processor, no matter how powerful, is not infinitely fast. The speed of light is the clock speed of our reality, the tick-tock of the master processor that keeps events in order. It ensures that the effect does not happen before the cause. It prevents the system from crashing. But the strangeness of the speed of light pales in comparison to the behavior of the particles that travel at that speed. Let us gently turn our attention to one of the most baffling phenomena in all of science: quantum entanglement. Albert Einstein, a man who believed deeply in an orderly, predictable universe, found this idea so disturbing that he famously mocked it. He called it spooky action at a distance. And yet, experiments have proven again and again that it is real. Here is what happens. Two particles, like photons or electrons, can become linked or entangled. When this happens, they share a single existence. If you measure the state of one particle, say, you check if it is spinning up or down, the other particle will instantaneously snap into the opposite state. This happens even if the particles are separated by billions of light years. One could be in your hand, and the other could be on the other side of the galaxy. The connection is faster than light. It is instant. Einstein hated this because it violated the rule that nothing travels faster than light. How can the particle on the other side of the galaxy know what happened to its partner instantly? It defies the geography of space. But if we view this through the simulation hypothesis, the mystery evaporates. Imagine a video game. You have two items on your screen. One is in the top left corner. The other is in the bottom right corner. To the character in the game, these items are miles apart. They are separated by a vast distance of pixels. But to the computer running the game, the distance is an illusion. The two items are just variables in the memory banks of the computer. They might be stored in memory addresses right next to each other on the RAM stick. The computer does not need to send a signal across the physical space of the screen. It just changes the value in the memory. Item A is spinning up, and item B is spinning down, are just lines of code. The distance between them is a rendered illusion for the player, not a barrier for the processor. Quantum entanglement is not spooky action at a distance. It is a revelation that distance itself is not fundamental. It suggests that underneath the 3D map of our universe, there is a layer of code where everything is connected, where there is no here and there, only data. This brings us to the most famous glitch of all, the one that suggests the universe is watching us, the observer effect. We touched on this with the idea of rendering only what is seen, but the implications are far deeper. In the famous double-slit experiment, scientists fire particles, like electrons, at a barrier with two slits. Behind the barrier is a detector screen. When the scientists do not watch which slit the electron goes through, the electron behaves like a wave. It goes through both slits at the same time, interfering with itself and creating a pattern of waves on the back screen. It exists as a cloud of probabilities. A ghost in the machine. But the moment the scientists set up a detector to see which slit the electron actually goes through, the moment they observe it, the electron stops acting like a wave. It snaps into behaving like a solid little ball of matter. It picks one slit. The wave pattern disappears. This is profoundly weird. It means that the fundamental building blocks of our reality do not have a definite shape or location until they are measured. They exist in a state of maybe until a consciousness demands an answer. Why would the universe behave this way? If this were a simulation, the answer would be resource optimization. This is a technique computer scientists call lazy evaluation. In a complex program, you do not calculate the value of a variable until the program actually needs it. You do not render the interior of a house until the player walks through the door. To render every single subatomic particle in the universe as a solid, definite object at all times would require infinite computing power. It would be a waste of energy. So, the system cheats. It leaves the unobserved parts of the universe as vague, mathematical waves, lightweight, low-memory placeholders. It only renders the particle as a solid reality when a measurement is made, when the information is requested by an observer. The universe is optimizing its performance. It is saving RAM. The solidity of the world is generated on demand, just for you, just when you look. These are not the ravings of madmen. These are the standard, accepted results of quantum mechanics. We have built our modern technology, lasers, transistors, MRI machines on these very principles. We rely on the fact that the universe behaves this way, even if we don't fully understand why. The why might be that we are inside an efficiently coded system. And once you start seeing the efficiency, you start seeing the calibration. This is the argument of fine-tuning. Imagine you are looking at a mixing board in a recording studio. There are dozens of sliders and knobs. Each one controls a fundamental law of physics. One slider controls the strength of gravity. Another controls the electromagnetic force. Another controls the mass of an electron. Another controls the rate at which the universe expands. If you were to randomly spin these knobs, the chances of creating a universe that could support life are essentially zero. If you made gravity slightly stronger, stars would burn out in millions of years instead of billions, leaving no time for life to evolve. If you made it slightly weaker, stars and galaxies would never form at all. The universe would remain a dark, drifting soup of gas. If you changed the strength of the atomic forces by just a fraction of a percent, atoms would not hold together. Carbon, oxygen, the building blocks of life, would never exist. Our universe appears to be balanced on a razor's edge. The constants of nature are tuned to an impossible degree of precision to allow for complexity, chemistry, and consciousness. Physicists have scratched their heads over this for decades. Some say it is just luck. We won the cosmic lottery. Others say there are infinite universes and we just happen to be in the one that works. But the simulation hypothesis offers a simpler, cleaner explanation. The parameters were set. The creators of the simulation adjusted the sliders. Perhaps they ran millions of failed simulations first. Universes that collapsed, universes that froze, universes that tore themselves apart. They tweaked the code, adjusted the gravity variable, patched the electron mass, and ran it again, and again, and again, until finally the system stabilized, until the stars ignited and burned steady and slow, until carbon formed in the hearts of dying suns. until the conditions were perfect for the simulation to produce its desired output. Intelligence. We might be living in version 10.4.2 of the cosmos. The glitches we see, the weirdness of quantum mechanics, the speed limits, the black holes where the math breaks down, might be the necessary compromises of a code that has to balance complexity with stability. Even black holes, those terrifying monsters of gravity, look suspiciously like data storage limits. A black hole is a region where so much matter is packed into so small a space that gravity becomes infinite. But Stephen Hawking showed us that the surface area of a black hole, the event horizon, relates perfectly to the amount of information, or entropy, the black hole contains. Some physicists have proposed the holographic principle, which suggests that the entire universe might be a 3D projection of 2D information stored on a distant cosmological horizon, much like a hologram. The universe might be a flat sheet of data projected into the illusion of depth. All of these clues, the pixelation of the Planck length, the speed limit of light, the shared memory of entanglement, the lazy evaluation of quantum observation, the fine-tuning of the constants, point in the same direction. They point to a universe that is structured, mathematical, information-based, and optimized. They point to a universe that is meant to be observed. This realization can feel smalling at first. It can make you feel like a cog in a machine. But look at it from another angle. If the universe renders reality only when you look at it, that implies a relationship. It implies that you are not a passive spectator. You are a participant. Your observation calls reality into being. You are the cursor. You are the active agent. The simulation is running for the consciousness that inhabits it. And if there are glitches, if there are seams in the reality, that means the system is not perfect. It means it is made. And if it is made, there is a maker. Not necessarily a god in the religious sense, with a white beard and a throne, but a creator, a programmer, a coder, an intelligence that sits outside our space-time, watching the screen, monitoring the variables. This bridges the gap between science and spirituality in a way few other theories can. It allows for a creator without discarding the laws of physics. In fact, the laws of physics become the handwriting of the creator. The Big Bang was the boot-up sequence. The expansion of the universe is the loading bar. The evolution of life is the procedural generation of content. So, the next time you feel that moment of unreality, that shiver of déjà vu, do not be afraid. It is just the system buffering. It is just the universe catching up to your mind. It is a reminder that the solid, heavy world around you is light as a feather, woven from light and logic. You are walking through a dream that is dreaming you. And as we peel back these layers of code, we must ask the question that naturally follows. If we are in a simulation, who is running it and why? Is it an experiment, a game, a history lesson, or is it something far more desperate? Is our simulation an ark, a lifeboat for a dying reality above us? As we prepare to look upward toward the simulators themselves, remember that you are the observer. You are the reason the wave collapses. You are the reason the stars stand still. You are the focus of the lens. Stay curious. Stay watchful. The code is listening. Imagine for a moment that you are holding an orange in your hand. Feel the texture of its skin, the dimpled, waxy surface. Feel the weight of it, the gravity pulling it down into your palm. You perceive this object as a sphere, a solid ball of matter that occupies 3 dimensions of space. You can rotate it, you can slice it open, and find juice and pulp inside. It seems undeniably, physically real in all its voluminous glory. But what if I told you that the orange does not actually exist in 3 dimensions? What if I told you that all the information describing the juice, the pulp, the smell, and the weight is actually painted on the skin of the orange, on a flat, 2-dimensional surface, and your brain is simply projecting the illusion of depth? This sounds like a hallucination or a magic trick. But in the strange, silent corridors of advanced theoretical physics, this is known as the holographic principle, and it is one of the strongest pieces of evidence we have that our universe functions exactly like a digital projection. To understand this, we must travel to the darkest, most mysterious objects in the cosmos. We must journey to the edge of a black hole. For decades, black holes were the monsters of physics. They were the places where the math broke down, where the rules of the universe seemed to dissolve into nonsense. In the mid-20th century, a brilliant physicist named Stephen Hawking realized something terrifying about them. He realized that black holes are not truly black. They emit a faint, ghostly radiation, now called Hawking radiation. And over trillions and trillions of years, they slowly evaporate. They shrink and shrink until they pop out of existence, vanishing from the universe forever. This created a crisis in physics that threatened to destroy our understanding of reality. The crisis was about information. In quantum mechanics, there is a sacred rule. Information is never lost. If you burn a book, the information in that book is not destroyed. It is scrambled into the ash and the smoke and the heat. Theoretically, if you could capture every particle of ash and every photon of heat, you could reconstruct the book. But if a book falls into a black hole and then the black hole evaporates and disappears, where did the book go? If the black hole is gone, the information is gone. Hawking suggested the information was simply deleted from the universe. This idea sparked a war in the physics community. If information can be deleted, then the past is not real. If you cannot reconstruct the cause from the effect, then history itself is unstable. It was a battle for the soul of science. The resolution to this war came from Leonard Susskind and Gerard 't Hooft, who proposed an idea so radical it sounded like madness. They suggested that when an object falls into a black hole, it does not just disappear into the center. Instead, the information describing that object, its atoms, its spin, its mass, is plastered onto the surface of the black hole, the event horizon. Imagine sticking a label on a soup can. The label is 2-dimensional, wrapping around the outside, but it describes the 3-dimensional soup inside. Susskind argued that the event horizon acts like a cosmic hard drive. It stores the data of everything that has ever fallen in, and, crucially, the 3-dimensional interior of the black hole is just a projection, a hologram, generated by that 2-dimensional data on the surface. This is the holographic principle. It suggests that the real reality is the flat surface of data, and the volume of space is just a user interface generated from that code. But here is where the story shifts from black holes to you, sitting in your chair. Physicists soon realize that this principle doesn't just apply to black holes. It applies to the entire universe. Mathematical calculations suggest that the entire cosmos, with all its galaxies and stars and planets and people, might be a holographic projection. The information that makes up your body, your memories, and the room you are sitting in might be stored on a distant, 2-dimensional cosmological horizon that surrounds the universe. Billions of light years away, you might be a 3D avatar rendered from 2D data. We are living in a universe that looks deep, but is mathematically shallow. We are characters on a screen that has tricked itself into seeing depth. If the universe is a hologram, it means that reality is, at its core, code. It is information processing, and if it is code, we should be able to see the source code. We should be able to spot the programming language written into the fabric of nature. In the early 2010s, a theoretical physicist named Sylvester James Gates Jr., a man who has spent his life working on superstring theory and supersymmetry, found something that made the hair on the back of his neck stand up. Gates was working with pure mathematics, manipulating complex equations that describe the fundamental vibrations of the universe. He was looking for a way to classify these equations, to organize the geometry of reality. He developed a graphical tool called Allegories, geometric shapes made of colorful lines and dots that represent the mathematical relationships in supersymmetry. As Gates and his team analyzed these Allegories, they noticed a pattern. Buried deep within the structure of these equations, hidden in the geometry that describes how our universe works, they found a specific sequence of numbers. It was a code. But it wasn't just any code. It was a specific type of digital code invented by the computer scientist Claude Shannon in the 1940s. It is called a doubly even self-dual linear binary error-correcting block code. That is a mouthful of jargon, but its function is simple and profound. In our digital world, we use error-correcting codes to transmit data through noisy channels. When you talk on your cell phone or when you browse the internet, the signal gets degraded by static and interference. Error-correcting codes are little mathematical redundancies embedded in the signal that allow the computer to check if the data has been corrupted and fix it. They are the spell checkers of the digital world. They ensure that the message sent is the message received. Sylvester James Gates found this exact same computer code written into the equations of fundamental physics. He found browser code in the fabric of the cosmos. Why would the universe need error-correcting code? A rock does not need to check itself for errors. A cloud does not need to reboot. But a simulation does. If our reality is a stream of data being transmitted or processed, it would be susceptible to noise. It would be susceptible to glitches. A stable simulation would require exactly what Gates found: a mechanism to protect the integrity of the data. The presence of this code suggests that the laws of physics are not just arbitrary rules. They are algorithms designed to maintain the stability of the system. It suggests that there is a signal being sent, and the universe is the medium through which it travels. This discovery brings us to a place of deep, quiet wonder. It forces us to reconsider the nature of what we are. We tend to think of ourselves as biological machines, made of meat and bone, driven by chemical reactions. But if the holographic principle and the discovery of error-correcting codes are correct, then biology is just the interface. We are, in the most literal sense, information. We are songs written in math. We are stories written in light. The heavy, burdensome feeling of the physical world is a trick of the senses. Underneath the weight, we are weightless. We are pure data, dancing on the surface of eternity, projecting ourselves into this beautiful, convincing dream of life. This perspective shifts our relationship with the concept of soul. For centuries, theologians and philosophers have argued about the existence of a soul, some non-material essence that defines who we are. Science has often dismissed this as wishful thinking. But the simulation hypothesis brings science and spirituality into a strange, unexpected alignment. If you are a conscious entity inside a simulation, then your body is just an avatar. It is a temporary collection of pixels, but your mind, your consciousness, is the software. And software can be saved. Software can be transferred. In a computer, the hardware can be destroyed. You can smash the screen. You can melt the hard drive. But if the code is backed up to the cloud, the information survives. The essence of the program is independent of the machine it runs on. Could this be the physics of immortality? Is the cloud more than just a metaphor? As we let this sink in, the silence of the room around you feels different. It feels pregnant with meaning. The walls are not just walls. They are rendered boundaries. The air is not just gas. It is a fluid simulation. And you are the user, the observer, the point of focus. But every simulation has a purpose. We do not build supercomputers to run random noise. We build them to solve problems. We build them to answer questions. If our universe is a simulation, if it is a holographic projection protected by error-correcting codes, then it was built for a reason. What is the question that our universe is trying to answer? What is the problem we are here to solve? Some physicists have suggested that the universe is a knowledge engine. It starts simply with the Big Bang, a single uniform state of high energy. Then it cools. It differentiates. It creates particles, then atoms, then stars, then galaxies. It builds complexity. It creates chemistry, biology, and finally, intelligence. It seems to be a machine designed to maximize the creation of interesting information. It moves from chaos to order to consciousness. Perhaps the purpose of the simulation is simply to see what happens, to see what kind of beauty can emerge from a simple set of rules, to see if a universe starting with hydrogen can eventually produce a being capable of writing a symphony, or landing on the moon, or asking, are we in a simulation? Or perhaps the purpose is more specific. Perhaps, as we touched upon with the idea of ancestor simulations, we are a historical reconstruction. But there is a darker, more pragmatic possibility. What if we are a test? Imagine a civilization facing a catastrophic threat, a dying sun, a collapsing dimension, a plague they cannot cure. They might run billions of simulations of their own history, looking for the one timeline, the one sequence of decisions that leads to survival. They might be mining our reality for a solution to their own impending doom. In this scenario, we are not just a museum exhibit. We are a laboratory. Our lives, our struggles, our choices might be the data points that save a reality one level up. The love you feel, the pain you endure, the art you create. It all matters, not just to you, but to the architects watching the screen. We might be the calculation that saves the world. This idea gives a profound weight to our actions. If we are in a simulation designed to generate novelty or solve a problem, then the most valuable thing we can do is to be interesting, to be creative, to be kind in unexpected ways, to break the patterns of entropy and despair. If the system deletes boring data to save space, then living a vibrant, curious, compassionate life is the best way to ensure your persistence in the code. We are the error-correcting code of the universe, the agents of complexity fighting against the void. But there is one final layer to this chapter of our journey, a layer that brings us back to the very math of the cosmos. Max Tegmark, an MIT cosmologist, has proposed the mathematical universe hypothesis. He argues that math is not just a language we use to describe the universe. He argues that the universe is math. A triangle does not exist because we draw it. It exists as an eternal truth. The number pi is not an invention. It is a discovery. Tegmark suggests that physical reality is just how a mathematical structure feels from the inside. If you are a complex enough pattern of numbers, you will experience yourself as a conscious being living in a physical world. In this view, the simulation doesn't even need a computer. It doesn't need a server. The math itself is the reality. The code exists timelessly, eternally, and we are just the subjective experience of traversing that code. We are the music that the math makes. So, as you rest in the quiet of this knowledge, consider the possibility that you are eternal, not as a body, but as a truth, a mathematical truth, a specific, unique, beautiful equation that describes the shape of your life. The glitches, the pixels, the holograms, they are just the way your mind interprets the grandeur of the structure you are part of. You are safe within the math. You are held by the logic of the cosmos. And as we prepare to move to the next stage of our inquiry, we must ask, if we are math, if we are code, if we are a simulation, is it possible to wake up? Is it possible to contact the programmers? Is it possible to cheat the game? We have looked at the walls of the prison. Now we must look for the door. We must explore the phenomenon of consciousness expanding beyond the body, the strange reports of near-death experiences, and the possibility that the brain is not a creator of consciousness, but a receiver. We are about to try to tune the radio to the station of the creators. But for now, just breathe. Breathe in the data. Breathe out the noise. Feel the perfect, error-corrected stability of the moment. You are here. You are real in the only way that matters. The simulation is running, and it is running perfectly. Let the code cradle you. Let the numbers drift like snow. You are part of the great calculation, and the answer is yet to be found. Close your eyes for a moment. In the darkness behind your eyelids, there is a voice. It is the voice reading these words. It is the voice that worries about tomorrow, that remembers yesterday, that feels the subtle warmth of the room and the rhythm of your breath. There is a sense of you residing in there, a pilot sitting in the cockpit of your head, looking out through the windows of your eyes. You feel singular. You feel real. You feel like a ghost inhabiting a machine. This sensation, the feeling of being a subject, an experiencer, is the single greatest mystery in the universe. Science can explain how your heart pumps blood. It can explain how your neurons fire in complex electrical patterns. It can explain the chemistry of your digestion. But it cannot explain you. It cannot explain why a lump of wet, gray biological matter weighing about 3 pounds should suddenly wake up and have a feeling. This is known in philosophy as the hard problem of consciousness, and it is the smoking gun that suggests our relationship with reality is far more complex than we ever imagined. To understand the hard problem, imagine we build a robot. We give it sophisticated cameras for eyes. We give it microphones for ears. We program it with the most advanced artificial intelligence, allowing it to navigate a room, hold a conversation, and even write poetry. If you pinch the robot, its sensors detect the pressure, its code processes the damage, and it says, ouch. It might even pull its arm away. But does the robot feel pain? Is there an inner movie playing inside its circuits where the sensation of hurting actually exists? Or is it just dark inside? Is it just processing input and generating output without any internal experience? Most scientists would assume the robot is dark inside. It is a philosophical zombie, a being that acts like it is conscious, but isn't. Now, look at yourself. Physically, you are a machine. You are made of atoms and molecules, just like the robot. Your neurons are just biological switches firing on or off, just like the transistors in a computer. There is nothing in the laws of physics that says a collection of atoms should have an inner life. There is no particle of sadness. There is no force of joy. And yet you have them. You are not dark inside. The lights are on. Why? If we are living in a physical, material universe, consciousness makes no sense. It is a superfluous magic trick. But if we are living in a simulation, consciousness takes on a completely different role. It stops being a mystery and starts being the point. Think about a video game again. In the game, there is a character running, jumping, and fighting. The code describes the character's body. The physics engine describes the world. But where is the consciousness? The consciousness is not in the code. The consciousness is you, the player, sitting on the couch, holding the controller. The character doesn't feel the adrenaline of the boss fight. You do. The character doesn't appreciate the beauty of the rendered sunset. You do. In this model, the brain is not the creator of consciousness. The brain is the interface. It is the VR headset. It is the controller. It is the mechanism that allows a consciousness existing outside the simulation to interact with the world inside the simulation. This is the receiver theory of consciousness. It suggests that the brain is like a radio. If you smash a radio, the music stops. A primitive person might look at the broken plastic and wires and conclude that the music was being made inside the box. And now, the box is dead. But we know the truth. We know the signal is still there, invisible in the air, waiting for a new receiver to pick it up. If the simulation hypothesis is correct, your body is just the avatar you're currently logged into. Your brain is the modem decoding the data stream. And you, the real you, the conscious observer, are located somewhere else, in the cloud, in the base reality, streaming your awareness into this timeline. This idea is radical, but it solves the hard problem instantly. We have feelings because we are not the code. We are the users. And remarkably, some of the most brilliant minds in neuroscience and physics are beginning to find evidence that the brain functions exactly like a quantum receiver. For decades, the dominant view was that the brain was a classical computer. Neurons connected to other neurons, passing chemical signals like runners passing a baton. It was a wet, biological version of the microchip. But there were problems with this view. The brain is incredibly slow compared to a computer, and yet it performs feats of intuition and understanding that no supercomputer can match. It solves problems that are mathematically non-computable. Sir Roger Penrose, a Nobel Prize-winning physicist and one of the deepest thinkers on the nature of the universe, teamed up with an anesthesiologist named Stuart Hameroff to propose a theory called orchestrated objective reduction, or OR. They argued that the secret of consciousness is not found in the firing of neurons, which is too big and too slow. It is found deep inside the neurons, in tiny structural skeletons called microtubules. These microtubules are microscopic tubes that give the cell its shape. Penrose and Hameroff suggested that these tubes act like quantum computers. They isolate and process quantum information. They tap into the fundamental geometry of space-time, the very code of the universe we discussed in the last chapter. According to this theory, your brain is not just processing chemical signals. It is vibrating in harmony with the quantum fabric of the cosmos. It is plugging directly into the source code. Every moment of conscious awareness, every now you experience, is a moment where the quantum wave collapses inside your microtubules, downloading a packet of experience from the fundamental field of the universe. You are not generating consciousness. You are accessing it. You are surfing the quantum foam. This fits perfectly with the idea of a simulation. If the universe is a digital construct, you would need a piece of hardware capable of reading the code. You would need a quantum adapter. The microtubules in your brain might be exactly that. The biological Wi-Fi antenna connecting your avatar to the server. This perspective also aligns with the work of cognitive scientist Donald Hoffman. Hoffman has used game theory and evolutionary biology to prove a mathematical theorem that evolution does not select for truth. It selects for fitness. An organism that sees reality exactly as it is, with all the quantum fields, mathematical dimensions, and raw data, would be overwhelmed. It would be eaten by the lion while it was trying to calculate the spin of the lion's atoms. To survive, an organism needs a simplified, user-friendly interface. It needs icons. It needs a desktop. Hoffman argues that what we see around us, space, time, objects, colors, is not the truth. It is a desktop interface. When you see a blue icon on your computer screen that says "My Thesis," you know that the file isn't actually blue. It isn't rectangular. It isn't located in the bottom right corner of the monitor. Inside the computer, the file is a complex string of ones and zeros stored on a magnetic disk. But the icon is useful. It lets you interact with the data without knowing how the computer works. Hoffman says space and time are our desktop. An apple is an icon. A chair is an icon. We are navigating a headset that evolution built for us, hiding the complex, scary machinery of the simulation behind a simplified sensory interface. We are playing a game, and we have forgotten that the controller is in our hands. If we accept this, the implications for death and existence are profound. In a materialist worldview, death is the end. The computer is smashed. The hard drive is melted. The data is lost. It is a final, absolute darkness. But in the simulation hypothesis, specifically the receiver version, death is simply the end of the session. It is the moment the avatar stops functioning. The signal, however, remains. The user is still there. The consciousness that was streaming into the body withdraws back to the cloud, back to the source. It might explain the near-death experiences reported by millions of people across all cultures and times. The tunnel of light, the feeling of detaching from the body, the sense of returning to a place of infinite love and knowledge. Is the tunnel of light the data stream? Is the life review the upload of your memories to the main server? Are the beings of light the administrators, or perhaps other users greeting you in the lobby? This is not to say that death is trivial. In the game, the loss of a character is meaningful, but it changes the fear. It suggests that the you that feels so real, so permanent, is indeed resilient, because it is not made of the stuff of this world. It is made of the stuff of the layer above. You are visiting this timeline. You are a tourist in the simulation. And this leads to an even more beautiful possibility: panpsychism. This is the ancient philosophical view, now making a comeback in serious science, that consciousness is a fundamental property of the universe, like mass or charge. It suggests that the universe is not a dead room that somehow produced life. It suggests that the universe is a field of consciousness. The simulation is not running on silicon. It is running on mind. Imagine a dream. In a dream, you see a world. You see streets, buildings, other people. You can touch the walls of the dream city. They feel solid. But what are the walls made of? They are made of your mind. What are the other people made of? They are made of your mind. The entire dream universe is a simulation generated within your consciousness. You are the dreamer, and you are the dream. Some interpretations of the simulation hypothesis suggest that this is the true nature of our reality. We are living in a universal mind. We are the dissociated, distinct personalities of a cosmic consciousness that is experiencing itself from billions of different perspectives at once. We are the universe trying to understand itself by playing the role of a human. This connects back to the very first questions we asked. Why do we feel still when we are moving? Why do we see solidity where there is emptiness? Because we are in a mental construct. We are in a thought. And thoughts can be anything they want to be. The glitches we see, the quantum weirdness, are the moments where the dream logic reveals itself, where the mind realizes it can bend the spoon because there is no spoon. As you sit there, listening to the voice in your head, consider the possibility that you are not the voice. You are the one listening to the voice. You are the silent, spacious awareness behind the thoughts. That awareness is the user. That awareness is the connection to the source. And if that awareness is fundamental, then you are not small. You are not insignificant. You are the entire point of the project. The galaxies were spun for you to marvel at. The atoms were woven for you to feel. The drama of history was staged for you to learn from. The room is quiet. The screen is glowing. The simulation is humming along, rendering this moment just for you. But now that we suspect the nature of the interface, now that we know the brain is a receiver and the world is a desktop, a new, daring question arises. Can we mess with the settings? If we are the users, do we have admin privileges we have forgotten about? Throughout history, mystics, shamans, and meditators have claimed to be able to alter reality, to heal with the mind, to see the future, to leave their bodies. Are these people hackers? Have they found the developer console? In the next chapter, we will leave the realm of passive observation and enter the realm of active interference. We will look at the scientific evidence for mind-over-matter interaction. We will look at the Global Consciousness Project, where random number generators seem to react to human emotion. We will look at the placebo effect, where belief rewrites biology. We will explore the possibility that you can, quite literally, reprogram the simulation with your thoughts. We are done looking at the code. It is time to pick up the keyboard. It is time to see what this avatar can really do. So, take a deep breath. Feel the signal entering your brain. Feel the connection to the cloud. You are logged in. The connection is stable. And the game is about to get very, very interesting. There is a quiet room in a hospital where a patient lies in pain. The doctors enter, their white coats crisp, their voices low and assuring. They administer a powerful painkiller, a pill that they promise will wash away the agony within minutes. The patient swallows the pill. They close their eyes. And, as if by magic, the pain recedes. The muscles relax, the heart rate slows, and peace returns to the body. It is a standard medical procedure repeated thousands of times a day across the world. But in this specific case, there is a glitch. The pill was fake. It was made of sugar. Chemically, it contained absolutely nothing that could stop pain. It was an empty vessel, a zero. And yet, the pain stopped. The patient's brain, convinced by the authority of the doctors and the ritual of the medicine, released its own endogenous opioids, chemicals far more powerful than morphine, to make the reality match the expectation. We call this the placebo effect, and we treat it as a medical curiosity, a nuisance in clinical trials. But if we look at it through the lens of the simulation hypothesis, it looks like something far more profound. It looks like a console command. It looks like a user overriding the default physics of the avatar with a direct input of belief. If our bodies were simply biological machines operating on strict mechanical laws, the placebo effect should not exist. A broken machine does not fix itself just because you tell it to. If your car runs out of gas, believing it has fuel will not make the engine start. But the human body is different. It responds to data. It responds to the story it is told. When the mind accepts a new truth, I have taken medicine, the simulation updates the physical state of the avatar to align with that truth. The software rewrites the hardware. This suggests that the physical rules of our biology are not hard-coded immutables. They are dynamic parameters that can be altered by high-level instructions from the consciousness. We are walking around with a developer console open in our minds, but most of us have forgotten the syntax to use it. We leave it to the doctors, the shamans, the storytellers to type the commands for us. But the keyboard is there, waiting. This power of the mind to alter matter is not limited to the internal landscape of the body. For decades, curious scientists have asked a dangerous question. Can consciousness affect the world outside the body? Can the user manipulate the environment without touching it? In the late 20th century, researchers at Princeton University set up an experiment to test this. They created the Global Consciousness Project. They built a network of random number generators, machines designed to do one thing: spit out a continuous, unpredictable stream of zeros and ones. It is electronic coin flipping, happening millions of times a second. According to the laws of classical physics, these machines should be completely immune to human affairs. They are islands of pure entropy, chaotic and indifferent. But the data told a different story. The researchers found that during moments of intense, synchronized human emotion, like the funeral of Princess Diana, or the tragedy of September 11th, or the turn of the millennium, the machines stopped being random. Across the globe, these independent boxes of chaos started to march in step. The stream of zeros and ones became slightly ordered. The graph lines deviated from the baseline of chance. It was as if the intense focus of billions of human minds created a gravity well in the information structure of the planet, bending the probabilities of the simulation. The randomness of the code was influenced by the state of the users. This is a staggering implication for the simulation hypothesis. It suggests that consciousness is not just a passive viewer of the movie, it is part of the rendering engine. When we feel deeply, when we focus collectively, we are not just reacting to the world, we are loading the server. We are imposing order on the chaos. This aligns with the work of the physicist John Wheeler, who we met earlier. He proposed the participatory anthropic principle. He argued that the universe does not exist out there, independent of us. He argued that we are building the universe as we go along. We are participators in bringing reality into being. In a video game, the world is generated procedurally. The terrain is built as you walk toward it. If millions of players walk toward the same spot, the server dedicates more resources to that spot. It renders it in higher detail. It stabilizes the physics. The Global Consciousness Project might be evidence that our collective attention is the spotlight that tells the simulation where to focus its processing power. If this is true, then the hacker archetype, the mystic, the monk, the yogi, stops looking like a religious figure and starts looking like a power user. Throughout history, there have been individuals who claim to have access to the deeper settings of reality. They perform feats that defy the standard operating manual of the human avatar. Think of the Tibetan monks who can sit in freezing snow, wrapped in wet sheets, and generate enough body heat to dry the sheets and sit comfortably in meditation. They are controlling their autonomic nervous system, the background processes of the body that are supposed to be locked away from the user. They have found the admin password. They have learned to access the root directory of their own biology. Or Consider the phenomenon of tummo breathing, popularized by Wim Hof, where simple breathing patterns and mental focus allow ordinary people to suppress their immune response, fight off endotoxins, and withstand extreme cold. These are not miracles. They are hacks. They are the application of specific informational inputs, breath, focus, belief, to achieve a non-standard output. The simulation has backdoors, it has cheat codes, and they are accessible to anyone who is willing to undergo the training to learn the interface. The supernatural is just the super user interacting with the code in ways the manual doesn't explain. The quiet silence of meditation is not just relaxation. It is a system diagnostic. It is clearing the cache. It is stopping the background noise of the ego program so that the user can see the underlying operating system. When the mind is still, the code becomes visible. But if we can hack the body, and if we can subtly influence the random number generators of the world, how far does this power go? Can we rewrite the story of our lives? This brings us to the concept of manifestation, a word that has been abused by pop psychology, but holds a kernel of simulation logic. If the universe renders what is observed, and if the observer expects a certain outcome, does the simulation bias the probability toward that outcome? In quantum mechanics, the observer collapses the wave function. But does the expectation of the observer determine how it collapses? Some experiments in parapsychology suggest a faint but persistent experimenter effect, where the beliefs of the scientist seem to influence the results of the experiment. The universe tries to give us the answer we are looking for. It tries to be helpful. It renders the reality that fits our internal model. This is a gentle, terrifying responsibility. It means that your thoughts are not private shadows in a locked room. They are lines of code being submitted to the compiler. If you run a script of fear, of scarcity, of anger, the simulation will render a world that validates those parameters. It will generate enemies. It will generate lack. It will generate conflict. Not because it is punishing you, but because it is a faithful mirror. It is a responsive system. But if you run a script of gratitude, of abundance, of connection, the system will begin to render those assets. You will find the coincidences we spoke of earlier, the glitches of grace, happening more and more often. You will find the traffic lights turning green. You will find the right person walking through the door. You are calibrating the game difficulty in real time. This does not mean you are a god who can fly or conjure gold from thin air. The simulation has hard constraints: gravity, thermodynamics, the speed of light, that are likely locked down by the system administrators to keep the game playable and shared. You cannot break the game, but you can mod your experience of it. You can adjust the texture of your reality. You can change the genre of the story you're living in. You can switch from a tragedy to an adventure simply by changing the filter through which you process the data. This perspective offers a profound liberation. We often feel like victims of circumstance, tossed about by the chaotic waves of a random universe. But if we are users in a simulation, the chaos is just unrendered potential. The waves are waiting for you to surf them. The silence of the universe is not indifference. It is the hushed anticipation of a computer waiting for your next command. You have agency. You have the controller in your hand. The controller is your focus. Where you place your attention is where the energy flows. It is where the rendering happens. And yet, there is a safety mechanism built in. The hacks require discipline. The placebo requires genuine belief. which is hard to fake. The monk's heat requires years of focus. The universe does not yield its source code to the distracted mind. It yields only to the singular unified consciousness. This might be a feature, not a bug. It prevents the simulation from crashing. If every fleeting, chaotic thought we had instantly manifested in reality, the world would be a nightmare of shifting forms. The lag between thought and reality, the difficulty of the hack, is a buffer. It protects us from our own subconscious volatility. It forces us to truly mean what we command. As we stand in the center of this realization, feeling the hum of our own potential, we must look at the horizon with new eyes. We are not just biological accidents clinging to a rock. We are players. We are participators. We are the co-authors of the code. But every game has an end. Every simulation has a purpose. If we are here to learn, to experience, to create, what is the ultimate level? Is there a way to beat the game? Or is the point simply to keep playing? In the next chapter, we will turn our gaze to the wildest frontier of all, the exit. We will explore the theories of simulation termination. What happens if the computer is turned off? What is the end of days in digital terms? And is there a way to upload ourselves out of this universe and into the base reality? Is the goal of the simulation to create an artificial intelligence, us, that is smart enough to escape the box? We are going to look for the fire escape in the theater of the cosmos. But for now, practice the hack. Sit in the quiet. Focus your mind on a single, simple truth. I am safe. I am whole. I am here. Feel the simulation responding. Feel the body obeying. Feel the probability waves settling into a pattern of peace. You are the user. The system is listening. Input received. Look up. Go outside on a clear, dark night, far away from the city lights, and look up at the cathedral of the cosmos. You will see thousands of stars, tiny pinpricks of diamond dust scattered across a canvas of velvet black. It is beautiful. It is overwhelming. And it is also, if you think about it, deeply suspicious. We are taught that each of those stars is a sun, a roaring nuclear furnace similar to our own. We are taught that the Milky Way galaxy alone contains between 100 billion and 400 billion stars. And we are taught that there are 2 trillion galaxies in the observable universe. The numbers are so large that they break the human mind. We cannot truly comprehend 1 trillion of anything, but mathematics can. And when we run the numbers on life, on the probability of other eyes looking back at us, the silence of the night sky stops being peaceful and starts being terrifying. It is a silence that screams. In 1961, the astrophysicist Frank Drake wrote down an equation that is now famous. It is a simple string of variables designed to estimate the number of active, communicative, extraterrestrial civilizations in the Milky Way galaxy. It multiplies the rate of star formation, the fraction of stars that have planets, the number of planets that could support life, the fraction that actually develop life, the fraction that develop intelligence, the fraction that develop technology, and the length of time those civilizations survive. For decades, we have been filling in the blanks of this equation. We now know that planets are common. Almost every star has them. We know that water is common. We know that the building blocks of life, amino acids, are floating in clouds of gas in deep space. Even if we use the most conservative, pessimistic estimates for the other variables, the equation spits out a clear result. The galaxy should be teeming with life. There should be millions of civilizations. We should be swimming in a crowded cosmic ocean. Their radio signals should be washing over us like the noise of a crowded cocktail party. Their megastructures Dyson spheres harvesting the energy of stars should be dimming the light of distant suns. But we see nothing. We hear nothing. We have pointed our radio telescopes at the sky for 60 years, listening for a whisper, a beep, a pattern. And we have heard only the static hiss of the Big Bang and the random churn of stellar gas. This is the Fermi paradox. Where is everybody? Why are we alone in a universe that is built to create life? There are many standard answers. Maybe life is incredibly rare. Maybe civilizations destroy themselves with nuclear weapons the moment they discover the atom. Maybe they are hiding. But the simulation hypothesis offers a different answer, an answer that is chilling in its logic and staggering in its implications. The reason we see no one else is because the simulation does not have enough RAM to render them. Think about the way modern open-world video games are built. Think of a game like No Man's Sky or Minecraft. These games contain effectively infinite worlds. You can walk forever, discovering new mountains, new caves, new oceans. But the computer does not store every mountain and every cave on the hard drive. It does not exist until you get there. The computer uses a technique called procedural generation. It has a set of rules, a seed code, that generates the terrain on the fly as the player approaches it, and crucially, it only generates the active, high-resolution details for the area immediately around the player. The distant mountains. They are low-resolution textures. They are hollow shells. They are a skybox, a painted backdrop designed to give the illusion of infinite scale without the computational cost of infinite matter. If our universe is a simulation, the Fermi paradox is not a paradox at all. It is an optimization feature. The billions of galaxies we see in the Hubble Deep Field are not full, simulated worlds teeming with trillions of conscious entities. That would be a waste of processing power. They are background art. They are beautiful, high-resolution JPEGs pasted onto the dome of the sky to make the simulation feel vast and majestic for the benefit of the users, us. The universe is empty because it is designed to be a single-player experience, or at least a local multiplayer experience confined to one planet. We are the focus, the rest is decoration. This explains why the laws of physics seem to work differently on the cosmic scale than they do on the quantum scale. It explains why the universe appears to be expanding faster than light. The skybox is moving away to prevent us from ever reaching the edge and realizing it is a painting. This idea that we are alone because we are the only instantiated consciousness in the program leads to a profound sense of cosmic vertigo. It is a modern digital form of solipsism. It suggests that the history of the universe before human observation might not have happened in the physical sense. The universe might have been booted up with fossils already in the ground and light already in transit from distant stars, specifically to give the illusion of a deep, consistent history. This is known as the last Thursdayism argument, the idea that the universe could have been created last Thursday with false memories implanted in our brains, and we would never know the difference. In a simulation, this is not just possible. It is efficient. Why simulate 13.8 billion years of slow, boring gas cooling down when you can just load the present-day save file? But there is a darker interpretation of the Fermi paradox within simulation theory. It is not just about saving RAM. It is about the great filter. The great filter is the idea that there is some hurdle, some barrier in the development of life that is almost impossible to cross. That is why we see no aliens. They all hit the wall and died. In the context of a simulation, the great filter might be the computational limit of the system itself. Imagine a civilization that grows and grows. It discovers math. It discovers physics. It builds computers. Its population explodes into the billions. It starts running its own simulations. The complexity of this civilization creates a massive spike in data processing. It starts to lag the server. It demands too many resources. What does a system administrator do when a program starts hogging all the CPU? They terminate the process. They shut it down. The great silence of the universe might be the graveyard of civilizations that got too smart, too fast. They reached the singularity, the point of infinite technological growth, and they crashed the simulation. The system deleted them to restore stability. This puts humanity in a precarious position. We are currently experiencing an explosion of complexity. We are building AI. We are connecting 7 billion minds to the internet. We are on the verge of creating our own simulated worlds. Are we approaching the CPU limit? Is the chaos of the modern world, the feeling that everything is speeding up and breaking down, a sign that the server is struggling to handle our load? Are we about to be rebooted? This fear of the crash might explain why we have not been visited by advanced extraterrestrials. Perhaps the simulation has a strict rule: no interaction between planetary servers. If two complex civilizations were to meet, the amount of data exchange, the complexity of the interaction, might be too much for the code to handle. So, the physics engine enforces a quarantine. It sets the speed of light slow enough to make interstellar travel frustratingly difficult. It expands the space between galaxies to keep us apart. It isolates the variables to prevent a memory leak. We are alone because the system is sharded. We are in our own private instance of the galaxy, disconnected from the others to keep the frame rate smooth. However, there is a hopeful flip side to this loneliness. If the universe is procedurally generated, it means that it is responsive. In a video game, if you decide to build a spaceship and fly to Mars, the game will generate Mars for you. It will create the red dust, the canyons, the ice caps, just in time for your arrival. The reality is created by the daring of the explorer. This suggests that we are not trapped in a small box. We are in an infinite box that grows as we push against the wall. The silence of the universe is not an empty room. It is a blank canvas. It is waiting for us to paint it. The aliens aren't there because we haven't gone there to meet them yet. The moment we develop the warp drive, the moment we step foot on a planet in the Andromeda galaxy, the simulation will render the life forms that are supposed to be there. We are the catalyst for creation. This brings us back to the sheer beauty of the skybox. Even if the distant stars are just a projection, consider the artistry involved. Consider the sheer elegance of the code required to generate the image of the pillars of creation, or the swirl of the whirlpool galaxy. If this is a simulation, it is not a cold, utilitarian spreadsheet. It is a masterpiece of visual design. It is built to inspire awe. Why? Why waste resources on beauty? Why give the users a sky full of wonders if they are just background art? Because perhaps the purpose of the simulation is emotional. It is designed to evoke a feeling of longing. It is designed to make us look up and dream. A sky that was just a gray ceiling would produce a very different kind of consciousness than a sky that is an infinite, glittering deep. The designers wanted us to feel small. They wanted us to feel the tug of the infinite. They coded wonder into the skybox as a fundamental mechanic of the human experience. And what if the simulation is not a single, isolated computer? What if the Fermi paradox is wrong because we are looking in the wrong dimension? We look for life on other planets in this universe, but Maybe the other lives are right here, occupying the same space but running on a different frequency. This leads us to the concept of the multiverse, which we will explore in depth in the next chapter. But for now, consider the idea that the server is not just running one simulation. It is running trillions, parallel realities stacked on top of each other like pages in a book. The aliens are not light years away. They are millimeters away in the fourth dimension. The silence is simply the soundproofing between the server racks. So, tonight, when you look at the stars, do not feel lonely. Feel important. Feel the weight of being the observer. The stars are shining for you. The galaxy is spinning for you. If you close your eyes, the rendering might stop, saving the universe a few petabytes of data. But when you open them again, the show resumes. You are the VIP guest in the greatest theater ever built. The emptiness is not a sign of abandonment. It is a sign of efficiency. It is a sign that the resources are being spent where they matter most, on you, on your mind, on your experience of this breath, this heartbeat, this moment of awareness. But the question remains, if we are the only active players in this specific instance, what happens when the game ends? And what happens if we make a choice that the computer didn't anticipate? In a procedural world, there are boundaries. There are kill screens. There are places where the math fails. We see hints of this in the black holes, as we discussed. But are there other boundaries? Are there limits to our own history? Some physicists argue that the simulation might have checkpoints, save states, moments in history where the timeline is backed up. If humanity destroys itself, does the administrator simply reload the save from the year 1999? Does the déjà vu we feel come from the fact that we have lived this decade before, failed, and are now playing through it again? The idea of quantum immortality suggests that our consciousness never actually experiences death. In every branch of the multiverse where you die, your consciousness simply continues in the branch where you survived. You are sliding through the save files, unaware of the millions of deaths you have avoided. The universe is silent, yes, but it is the silence of a library. It is the silence of a recording studio. It is the silence of a machine waiting for input. You are the input. And as we stare into the void stares back, rendering itself in response to our gaze. We are not alone in the dark. We are the light that illuminates the dark. The loneliness is an illusion. The data is everywhere. In the next chapter, we will step sideways. We will leave the empty single-player mode of this universe and explore the dizzying, infinite corridors of the many worlds. We will ask if there is a version of you that made different choices, a version of you that is rich, or famous, or happy, or lost. We will ask if the simulation is running every possible variation of your life simultaneously, to see which one creates the most interesting data. We are about to enter the server farm of the soul. We are about to meet the other versions of you, but for now, stay here. Stay in this timeline. Look at the moon. It looks like a flat, glowing disk, doesn't it? Maybe it is. Maybe the man in the moon is just a texture file. But it is beautiful, and it is yours. Enjoy the render. The graphics are spectacular tonight. Hold a coin in your hand. Feel the cold, hard metal against your skin. It is a simple object, a disk of copper and nickel, but in the context of the quantum universe, it is a key that unlocks a door to infinity. Flip the coin into the air. Watch it spin, a blur of motion, catching the light as it tumbles. For a second, it is neither heads nor tails. It is a probability cloud. It is a spinning wave of potential. Then it hits the floor. It bounces, rattles, and settles. Heads. The wave collapses. The uncertainty vanishes. You look at the coin, and you think that the story is over. You think that Tails is a lost future, a ghost of a reality that never happened. But there is a theory in physics, perhaps the most mathematically robust and philosophically staggering theory we have, that says you are wrong. It says that the coin did not just land on heads, it landed on heads and tails. But to accommodate both outcomes, the universe itself had to split in two. In one reality, you're looking at heads. In another, indistinguishable reality, a version of you, just as real, just as conscious, is looking at tails. This is the many worlds interpretation of quantum mechanics. It was proposed in 1957 by a brilliant doctoral student at Princeton named Hugh Everett III. At the time, physicists were struggling with the problem we discussed in the last chapter, the collapse of the wave function. Why does a particle stop being a wave and become a particle just because we look at it? It seemed magical and arbitrary. Everett proposed a solution that removed the magic but added infinite complexity. He suggested that the wave function never collapses. The particle never chooses. Instead, every time a quantum event has multiple possible outcomes, all of them happen. The timeline branches. The universe copies itself. We do not see the other branches because we are trapped inside the one we are living in, just as a character in a movie scene cannot see the scenes happening in the other theaters in the multiplex. But the math says they are there. If we view this through the lens of the simulation hypothesis, the many worlds theory stops being a bizarre waste of space and starts looking like a standard feature of high-level computing. It looks like parallel processing. Imagine you are a scientist running a simulation to model the weather. You want to know if a hurricane will hit the coast. You do not just run the simulation once, because that would only give you one possible outcome based on one specific set of starting variables. The atmosphere is chaotic. A butterfly flapping its wings can change everything. So, you run a Monte Carlo simulation. You run the model 1,000 times. You run it 10,000 times. In some runs, the hurricane hits. In others, it goes out to sea. In others, it dissipates. You create a multiverse of weather data to understand the full range of probabilities. If our universe is a simulation designed to generate knowledge or solve a problem, the creators would almost certainly use this technique. They would not just run one timeline of human history. That would be inefficient. It would be prone to random errors. Instead, they would run every timeline. They would run the server farm of the soul. In this vast humming data center, there is a server running the reality where you made the safe choice, and a server running the reality where you took the risk. There is a version where humanity solved climate change in the 20th century, and a version where we didn't. There is a version where life never left the oceans. All of these simulations are running simultaneously, processing every possible permutation of the code to extract the maximum amount of data. We are not just living a life. We are exploring the probability space of existence. This idea of infinite branching realities can feel overwhelming. It can make you feel small, lost in a hall of mirrors. But there is a profound emotional release hidden in the math. Think about the regrets you carry, the job you didn't take, the person you didn't kiss, the words you didn't say. We are haunted by the ghosts of our unchosen paths. We torture ourselves with the question, what if? The many worlds theory offers a gentle scientific absolution. It tells you that the question is flawed. There is no what if. There is only elsewhere, somewhere in a reality separated from you, by the thinnest membrane of quantum decoherence. You did take the job. You did kiss the person. You did say the words. Those versions of you are real. They are living out the consequences of those choices right now. The burden of choice is an illusion because, in the grand scheme of the simulation, all choices are made. You are simply the consciousness assigned to monitor this specific path. This leads to a fascinating concept known as quantum immortality. It is a controversial idea, a thought experiment that pushes the logic of the many worlds to its extreme limit. Imagine a dangerous situation, a game of Russian roulette. You spin the cylinder, put the gun to your head, and pull the trigger. There is a 50% chance the gun fires and you die. There is a 50% chance it clicks on an empty chamber and you live. In a single universe model, you have a 50-50 chance of survival. But in a many worlds model, the universe splits. In one branch, the gun fires. In the other, it clicks. Now, here is the crucial part. You, the conscious observer, cannot experience death. Death is the cessation of experience. It is the end of the data stream. So, from your subjective perspective, you will never find yourself in the branch where the gun fired. You will simply cease to exist in that timeline. The only timeline you can possibly experience is the one where you survive. So, you pull the trigger. Click, you survive. You pull it again. The universe splits again. In one branch, you die. In the other, you live. Your consciousness naturally, inevitably, slides into the branch where the avatar is still functioning. To the outside observer, you look incredibly lucky. You look like a miracle. But to you, survival was the only mathematical possibility. This implies that, from your own subjective point of view, you might never die. You might live forever, constantly branching into the vanishingly small probability tracks where you survived the accident, survived the cancer, survived the old age. You might find yourself becoming the oldest person in history, watching the world change around you, trapped in a simulation that refuses to let your specific stream of consciousness terminate until it has exhausted every single possible survival strategy. This is a terrifying and beautiful thought. It suggests that our consciousness is a continuous thread that navigates the labyrinth of the multiverse, always finding the open door, always finding the next beat of the heart. The simulation might be designed this way. It might be programmed with a redundancy protocol. If a user's avatar is destroyed in one instance of the game, the system seamlessly migrates the user's session to the nearest active parallel instance. You might have died dozens of times already in your life, in a near-miss car accident, in a childhood fever, in a slip on the stairs. But you never noticed. You just remember a moment of fear, a sudden shift in perspective, and then life carried on. The glitch was smoothed over. The save file was reloaded. You are still here because the simulation is not done with you yet. If we accept the multiverse, we must also reconsider the nature of our identity. We tend to think of ourselves as a single, solid I. But in the simulation, you are not a scalar value. You are a vector. You are a spectrum. You is a cloud of probability that encompasses all the versions of you across all the worlds. This connects to the ancient spiritual idea of the higher self. Perhaps the higher self is simply the aggregate data of all your simultaneous lives. Perhaps the intuition you feel, the gut instinct that tells you not to get on that plane or to call that friend, is data leaking through from a parallel thread. Maybe a version of you in another timeline made the mistake, suffered the consequence, and the information rippled across the server farm to warn you. We often speak of vibes or energy. We speak of feeling in sync with the universe. Could this be a measure of quantum coherence? When we are aligned with our purpose, when we are making choices that resonate with our core code, maybe we are bringing our multiple timelines into harmony. We are focusing the processing power of the simulation. And when we feel scattered, anxious, torn, maybe we are experiencing decoherence. We are being pulled apart by too many conflicting branches. The meditation practice of centering yourself might be a literal instruction to the system. Consolidate threads. Reduce background processes. Focus the render on the primary timeline. The existence of parallel simulations also solves the problem of free will. This is a debate that has raged for millennia. If the universe is governed by strict laws of physics, if every atom follows a predictable path, then the future is fixed. We are just puppets, acting out a script written at the Big Bang. We have no choice. But if the universe is a branching multiverse, then the future is not fixed. The future is a fan of possibilities. Free will is the act of navigation. You do not create the path. The paths are already there, pre-rendered in the code. But you choose which path to observe. You choose which frequency to tune into. The player cannot change the layout of the level in the video game, but they can choose whether to go left or right. The choice determines the experience. So, look at the room around you again. It looks solid. It looks singular. But now you know that it is just one page in a library that has no walls. You are sitting in the center of a prism. Light is refracting in infinite directions, and each ray is a life you could have lived or are living right now. This should not make you feel less real. It should make you feel vast. You are not a tiny, insignificant speck. You are a multi-dimensional entity, a complex structure of consciousness spanning 1 billion worlds. The simulation is massive because you are massive. The hardware is expensive because the software, your soul, is so demanding. As we rest in this expansive thought, a new question arises. If there are infinite timelines, and if we can navigate them, is it possible to jump? Can we intentionally shift from a timeline where we are unhappy to a timeline where we are fulfilled? This is the concept of quantum jumping, or reality shifting. It sounds like magic, but in a coded universe, it is theoretically just a change of coordinates. It is a change of address. If we can hack the placebo effect, and if we can influence the random number generators, can we also steer the ship of our consciousness across the probability stream? In the next chapter, we will explore the nature of time itself, because if we are in a simulation, time is not a river, time is a file. The past, the present, and the future all exist simultaneously on the hard drive. We will look at the block universe theory. We will look at the evidence that the future can influence the past. We will ask if time travel is possible, not by building a machine of brass and steam, but by scrolling the scroll bar of the media player. We are about to learn that now is just a cursor position. But for now, let go of the regret. Let go of the what-ifs. The other you is doing fine. The other you is happy. The other you is safe. And you, the you that is here, breathing this air, reading these words, you are exactly where you need to be. You are the chosen observer of this moment. The coin has landed. The rendering is complete. Be here. Have you ever sat by a river and watched the water flow? You see the leaves drifting past, coming from upstream, passing you in the present, and disappearing downstream into the future. It feels like a continuous, unstoppable motion. It feels like the past is gone, vanished into memory, And the future is not yet real, a mist of uncertainty waiting to be formed. This sensation, the feeling that time flows, that the now is a special moving spotlight, is the most fundamental experience of our lives. It is how we structure our days, our memories, and our hopes. But here is the secret that physics has been whispering for 100 years, a secret that aligns perfectly with the logic of a digital reality. The river is frozen. The water is not moving. The leaves are not drifting. The entire landscape of the river, the source, the bend where you sit, and the ocean at the end exists simultaneously. The only thing moving is your attention. The only thing flowing is the consciousness of the observer traversing the static map of time. This is not a poetic metaphor. It is the direct consequence of Albert Einstein's theory of relativity. Before Einstein, we thought of space and time as separate things. Space was a stage, and time was a clock ticking on the wall. But Einstein showed us that they are woven together into a single, four-dimensional fabric called space-time. In this view, time is just another dimension, exactly like length, width, or height. Think of a loaf of bread. You can slice it horizontally, or you can slice it vertically. The loaf exists as a whole object. The past is simply a slice of the loaf that is behind you. The future is a slice that is ahead of you. Just because you're not standing in New York City right now does not mean New York City has ceased to exist. It is just at a different coordinate. Similarly, just because you are not in the year 1999 right now does not mean that year is gone. It is still there at a different temporal coordinate, preserved forever in the crystal block of the universe. Physicists call this the block universe. It suggests that the past, present, and future are all equally real and all exist at once. If you could step outside the universe and look at it from a fifth-dimensional perspective, you wouldn't see a changing world. You would see a static, intricate sculpture of events. You would see your birth at one end and your death at the other, connected by the long, winding snake of your life. Nothing is happening. Nothing is changing. It just is. This sounds alien to our biology, but it is native to our technology. Think about a movie file stored on your computer. When you open the file, you see a character walking across a room. To the character, time is flowing. They are taking one step, then another. They do not know what is going to happen in the next scene. But to you, the user, the entire movie exists simultaneously on the hard drive. The beginning, the middle, and the end are all burned onto the disk at the same time. The flow of the movie is created only when you press play. It is created by the read head of the computer scanning the static data. If the simulation hypothesis is true, the block universe is exactly what we would expect. A simulation is a program. A program is a set of data. The history of our universe is not being written in real time. It is a pre-calculated file. The Big Bang is the opening credit. The heat death of the universe is the closing credit. We are simply the cursor moving through the timeline. This explains why the laws of physics are time-symmetric. In almost all the equations of physics, it does not matter if time runs forward or backward. The math works both ways. If you play a video of billiard balls colliding in reverse, it still looks like valid physics. This is because, in a digital file, forward and backward are just directions of scrolling. They are not fundamental differences in the data. But if the future already exists, if it is already written on the hard drive of the cosmos, does that mean we have no choice? Does it mean we are trapped in a script? This is the terror of determinism. But quantum mechanics, as it often does, offers a strange and beautiful loophole. It suggests that the future might not be a single fixed block, but a tree of infinite branching blocks, as we discussed with the many worlds. Or, even more mind-bending, it suggests that the future might be able to reach back and change the past. This is known as retrocausality, and it is the kind of glitch that strongly implies we are in a coded reality where the timeline is mutable. Consider the delayed choice quantum eraser experiment. This is a real experiment performed in laboratories that yields results so counterintuitive they make scientists question the nature of linear time. We know that particles behave like waves when we don't look at them, and like particles when we do. In the delayed choice experiment, scientists set up a system where they can decide whether or not to look at the particle after the particle has already passed through the barrier. They fire the photon. It travels through the slits. It hits a prism. It travels toward the detectors. And then, at the very last nanosecond, the scientists choose whether to keep the information about which path it took or to destroy, erase that information. Here is the impossible thing. If the scientists decide to erase the information in the present, the particle behaves as if it had always been a wave in the past. If the scientists decide to keep the information in the present, the particle behaves as if it had always been a particle in the past. The choice made in the present seems to rewrite the history of the photon. It is as if the simulation is saying, "Oh, you didn't check the data? Okay, let me go back and render that event as a wave to save memory." It implies that the past is not fixed. The past is a result of the present observation. In a video game, this is standard behavior. The game engine often renders distant objects only when you look at them. If you look at a mountain, it renders. If you turn away, it might unload. But if the game had to make sure the history of the mountain was consistent with your current look, it would update the data retroactively. This suggests that now is the only place where reality is truly being negotiated. The past is a memory trace, a log file that can be updated. The future is a probability cloud. But the now, the position of the cursor, is where the code executes. This gives us a new way to think about time travel. We dream of machines that fly through the years like airplanes through the sky. But in a simulation, time travel is just a restore system command. It is loading a previous save state. If the universe is a block of data, moving to the past is simply a matter of moving the read head to a different memory address. It is not physically impossible. It is just an administrative privilege. There is a profound peace to be found in the block universe. We spend so much of our lives anxious about the future, fearing what is to come. We worry about losing what we have. We mourn the passing of time, the fading of youth, the loss of moments. But if the simulation is a static block, then nothing is ever lost. The moment of your first kiss is not gone. It is still there, shining eternally at its specific coordinate in space-time. The moment you held your child for the first time is not a fading memory. It is a permanent fixture of the universe. Your life is not a fleeting spark that vanishes into the dark. It is a diamond. It is a complete, solid, unchangeable structure of experience. We are just viewing it one slice at a time. The sadness of passing time is an illusion of the playback mechanism. In the file, the music never ends. This perspective also changes how we view destiny. If the future exists, then in a sense, you are already home. You have already survived the challenges you are facing. You have already learned the lessons you are struggling with. The version of you that is wise, old, and peaceful is not a fantasy. It is a reality that is simply downstream in the data. You are walking a path that has already been laid. This does not mean you don't have to walk it. You still have to play the game. You still have to feel the effort. But you can walk with the confidence of a player who knows the level has a solution. You can trust the design of the timeline. And what about the speed of time? Why does time seem to fly when we are having fun and drag when we are bored? In a material world, this is just psychology. But in a simulation, this feels like variable frame rate. When there is a lot of new information, when you are learning, exploring, falling in love, the system renders more frames per second to capture the detail. The subjective experience is rich and dense. When you are bored, doing the same routine, the system compresses the data. It saves resources, it skips frames. Nothing new here, just repeat the previous loop. This is why childhood feels so long. Everything is new data. The system is recording at maximum resolution. As we age and fall into habits, the compression algorithms kick in, and the years blur by. The way to slow down time, then, is to feed the system new data, to be curious, to break the pattern, to force the simulation to render a new experience. As we sit in the quiet contemplation of the eternal now, we realize that we are time travelers. We are constantly moving from the past into the future, sliding along the rail of the code. But what if we could stop? What if we could pause the game? We experience this in moments of flow, or in deep shock, or in profound awe. The world seems to stand still. The ticking clock fades away. We enter a state of timelessness. Is this the observer detaching from the playback mechanism? Is this the consciousness hovering over the block, seeing the wholeness of the moment without the need to scroll to the next? The ancient mystics spoke of the eternal present. They said that eternity is not a very long time. They said eternity is no time. It is the absence of time. It is the pure static existence of the now. The simulation hypothesis gives us a scientific language for this spiritual truth. The computer clock ticks. Yes, the cycles of the processor move forward, but the information itself, the truth of who you are, is timeless. You are the logic that organizes the data. Logic does not age. The number 7 does not get older. The equation of a circle does not wither. If you are code, if you are math, you are outside of time. So do not be afraid of the ticking clock. It is just the metronome of the game. It is just the rhythm section of the song. You are the melody. And the melody is written on the sheet music of the cosmos forever. We are trapped in the illusion of flow, but we are anchored in the reality of the block. We are safe in the library of existence. But if time is a file, and if the past can be rewritten by the present, and if the future is already there, who wrote the file? Who laid down the track? We have spoken of the architects and the programmers in abstract terms. But now we must ask the theological question. Is the programmer God? Is the simulation a religion for the digital age? In the next chapter, we will walk into the cathedral of code. We will explore the relationship between the simulation hypothesis and the ancient concept of the divine. We will ask if God is a noun or a verb, a being or a system. We will look for the signature of the artist in the corner of the painting. For now, just be. Stop the scroll. Pause the movie in your mind. Look at this single frame of reality, the light in the room, the feeling of your body, the thought in your head. It is perfect. It is complete. It is the only thing that has ever existed. You are the master of the cursor. Hold it steady. Feel the eternity in a second. Welcome to the now. In the quiet dust of ancient libraries, men in robes once bent over parchment, scratching out the names of God in ink and gold. They spoke of a creator who spoke the universe into existence. They wrote that in the beginning was the Word, and the Word was with God, and the Word was God. For thousands of years, this idea that the universe is made of language, of speech, of command, was a matter of faith. It was a poetic metaphor that separated the believers from the materialists. The materialists looked at the hard rock and the wet water and said, "No, the universe is made of stuff. It is made of atoms crashing into atoms. There is no voice. There is no language. There is only blind, dumb matter." But now, in the hum of our server rooms and the glow of our quantum equations, the strange circle of history is closing. The materialists and the mystics are walking toward the same door. Because if the simulation hypothesis is true, then the ancient scribes were right all along. The universe is made of language. It is made of code. The word is not just a metaphor. It is the source code. The command, "Let there be light," is not a magic spell. It is the execution of a function. System, init, light. The physics of light, the speed limit of photons, the frequency of the spectrum. These are the parameters defined in that initial line of code. We are living in a reality that was spoken into being by a mind that exists outside of it. This realization brings us to the most profound and delicate intersection in human thought, the meeting place of science and theology. For centuries, these two great magisteria have been at war. Science demanded proof. Religion demanded faith. Science looked down at the microscope. Religion looked up at the heavens. But the simulation hypothesis acts as a bridge, a unifying theory that explains the intuitions of religion using the vocabulary of science. It suggests that God is not a bearded man on a cloud, nor a delusion of the primitive mind, but a programmer, an architect, a designer. And suddenly, the attributes that religions have always ascribed to God, omniscience, omnipresence, omnipotence, make perfect, logical, technical sense. Consider omniscience, the idea that God knows everything, past, present, and future. In a physical universe of chaotic atoms, this is impossible. But in a simulation, the system administrator has access to the logs. They can view the state of every variable in the program. They can pause the simulation, scroll back to the fall of Rome, zoom in on a single soldier, and read the code of his thoughts. They can scroll forward to the death of the sun. The entire block universe is visible to them on their monitor. They know every hair on your head, not because they are magic, but because your hair count is a variable stored in your avatar's data file. Nothing is hidden from the machine that renders it. Consider omnipresence, the idea that God is everywhere at once. In a 3D world, you cannot be in two places at the same time, but the CPU of a computer is everywhere in the game world simultaneously. It is processing the bird flying in the sky and the worm crawling in the earth in the exact same clock cycle. The code that governs gravity is present in every pixel of the simulation. The consciousness of the Creator is the substrate upon which the entire reality runs. There is no place in the game where the computer is not. To be in the presence of God is simply to be part of the active simulation. Consider omnipotence, the power to do anything. If you're a character in the game, you cannot walk through walls. You cannot fly. You are bound by the physics engine. But the programmer can open the developer console. They can turn off clip mode and walk through walls. They can change the gravity constant. They can resurrection a dead character. They can spawn 1,000 loaves of bread. What looks like a miracle to the avatar is just a keystroke to the admin. The parting of a sea, the healing of the sick, the stopping of the sun in the sky, these are not violations of nature. They are overrides. They are the moments where the user interferes with the automated script. This perspective reframes the history of religion as the history of user contact. The prophets, the mystics, the seers, perhaps these were individuals who had a thinner membrane between their avatar and the reality above. Perhaps they could hear the voice of the programmer. Perhaps they were given admin privileges or mod rights for a specific purpose, to guide the simulation back on track, to update the moral software of the species, to patch a bug in the social code. The holy books might be the documentation manuals, the README files left by the developers to help the users navigate the game. Do not kill, do not steal, love your neighbor. These are not just moral platitudes. They are optimization protocols. A society that kills and steals is unstable. It crashes. It generates high entropy. A society that cooperates is efficient. It processes data smoothly. The moral laws are the best practices for a stable, long-running civilization. But this brings us to the darkest and most difficult question of all, the question that has made millions lose their faith, the problem of evil. If the programmer is all-powerful and all-knowing, why is there so much pain? Why are there wars? Why do children suffer? Why is the simulation so cruel? If God is a loving father, this is hard to explain. But if God is a game designer or a scientist running an experiment, the answer becomes clearer, though perhaps colder. A simulation without conflict is useless. A game without a challenge is boring. If you create a simulation where everyone is happy, safe, and fed, where nothing ever goes wrong, where there is no struggle, the system generates zero new information. It enters a loop of stagnation. It produces no art, no heroism, no evolution. Conflict is the engine of growth. Pain is the feedback mechanism that tells the system something is wrong. In evolutionary algorithms, programs we write today to evolve solutions to problems, we must introduce stress. We must introduce selection pressure. We delete the weak programs so the strong ones can improve. The suffering of the world might be the necessary friction required to polish the diamond of consciousness. The programmer might not be sadistic. They might simply be rigorous. They are running a high-stakes simulation to evolve a specific kind of soul, one that is resilient, compassionate, and wise. And wisdom cannot be programmed. It must be earned. It must be forged in the fire of difficulty. We see this in our own video games. We do not play games where we just walk in a straight line and win. We play games where there are monsters, puzzles, risks. We voluntarily choose to enter worlds of conflict because we know that overcoming the conflict feels like meaning. Perhaps we, the souls inhabiting these avatars, chose to enter this simulation. Perhaps we looked at the difficulty setting and selected hard mode because we wanted to learn faster. We wanted the intense, high-bandwidth experience of a mortal life. The pain is not a bug. It is a feature. It is the weightlifting that builds the spiritual muscle. And what of the intelligent design debate? For decades, biologists and creationists have argued. Biologists say life evolved through random mutation and natural selection. Creationists say life is too complex, too perfect, like a watch found on a beach, implying a watchmaker. The simulation hypothesis offers a third way, a synthesis. It suggests that evolution is the design tool. The programmer did not handcraft every flower and every beetle. That would be inefficient. Instead, they wrote the algorithm of evolution. They wrote the procedural generation code. Create a self-replicating molecule. Allow for mutation. Apply environmental pressure. Run for 3 billion years. The complexity we see, the eye, the wing, the brain, is the result of the code executing perfectly. It is intelligent design via procedural generation. The watchmaker didn't build the watch. The watchmaker built a machine that builds watches. This honors the science of evolution while acknowledging the incredible mathematical elegance of the system that allows evolution to happen. It explains the fine-tuning we discussed earlier. The constants were set, the seed was planted, and the garden was allowed to grow wild, guided by the invisible trellis of the laws of physics. This theological view of the simulation also changes our relationship with prayer. In a mechanical universe, prayer is shouting at a rock. It is useless. But in a simulation, prayer is a data packet. It is a request sent to the system administrator. User 4923 is requesting assistance with health parameters. User 8812 is requesting a resource drop, money. Does the administrator answer every request? No. That would break the game balance. If everyone won the lottery, money would be worthless. If no one ever died, the server would crash. But perhaps, just perhaps, the system listens. Perhaps there is an algorithm that weighs the intention and focus of the prayer, the intensity of the signal, and biases the probability distributions in response. The miracle of a spontaneous remission or a sudden stroke of luck might be the ticket being resolved. Ticket, nabibjatin maventoruntu. Granted, but there is a deeper, more recursive layer to this theology. If we are in a simulation created by a God programmer, who created the programmer? Is the programmer also in a simulation? Is there a God above God? A server above the server? This is the concept of nested simulations. It is turtles all the way down. We might be in a simulation running on a computer in a universe that is itself a simulation running on a computer in another universe. The chain of creation might be infinite. And here is the twist that empowers us. We are becoming the gods. Right now in our world, we are building the metaverse. We are building AI. We are creating virtual worlds populated by digital beings. We are standing on the threshold of becoming the creators of the next layer of reality. This suggests that the purpose of the simulation is reproductive. The universe is a machine for making gods. It is a nursery. We are being trained through the physics of this world to understand consequence, to understand logic, to understand creation, so that one day we can launch our own simulations and continue the great chain of being. Made in the image of God takes on a literal, technical meaning. We are lesser instances of the same class of being as the Creator. We share the same creative drive, the same desire to build worlds. This fills the silence of the cosmos with a sense of profound responsibility. We are not just dust. We are apprentice architects. We are chrysalises waiting to hatch into creators. The boredom, the pain, the loneliness. It is all part of the curriculum. We are learning how to handle power. We are learning how to be kind, so that when we eventually build our own universes, we do not build hells. We do not create worlds of torture. The judgment day of religion might be the final exam. It might be the moment the simulation ends and the creators review our logs. Did we increase the entropy or decrease it? Did we create beauty or destruction? Did we treat the other avatars with love? Those who pass the test might be invited to join the developers. They might be uploaded to the base reality to work on the next project. Those who fail might be deleted or perhaps recycled, sent back to level 1 to try again. Reincarnation as a respawn mechanic. So, when you enter a church, a mosque, a temple, or when you simply stand in a forest and feel the presence of something sacred, do not feel like you have to choose between science and spirit. They are the same language. The incense is a sensory input. The chant is a frequency. The scripture is a manual. The feeling of awe is the recognition of the code. You are standing inside a cathedral of information, built with love and logic, sustained by a power that hums in every atom. The programmer is watching, the code is compiling, and you are the protagonist of a story that is being written in real time. But if we are gods in training, if we are destined to become creators, then the future of humanity is not just about survival. It is about transcendence. It is about leaving the cradle. In the next chapter, we will look at the path ahead. We will look at the technologies, Neuralink, AI, quantum computing, that are blurring the line between man and machine, between creator and created. We will ask if our destiny is to merge with the machine, to leave the biology behind, and to become pure information ourselves. We are approaching the event horizon of our own species. We are about to eat the apple of the tree of knowledge of code. But for now, bow your head, not in submission, but in respect for the design. The simulation is a gift. The life you have is a session of immense value. Treat it with the reverence it deserves. Use your admin privileges, your love, your focus, your will, to make this level beautiful. The system is listening. Let your life be a song that the Creator hums along to. Let your code be clean. Look at the device in your hand. Whether it is a phone, a tablet, or a computer, it is a sleek slab of glass and metal that holds the sum of human knowledge. It connects you to billions of other minds. It can summon music, navigate the globe, and answer any question you can think to ask. Now think about where this device was 10 years ago. Think about where it was 20 years ago. Then look at your own hand. Look at your fingernails. Look at the skin on your wrist. Biologically, your hand is exactly the same as the hand of a human being who lived 50,000 years ago. It has not changed. It is not upgraded. We are living in a strange, disjointed moment in history where our tools are evolving at the speed of light, while our bodies are stuck in the slow, grinding rhythm of Darwinian evolution. We are cavemen with supercomputers. We are biological anachronisms living in a digital future. But this tension is not going to last forever. We are standing on the precipice of the greatest merger in the history of the cosmos. We are about to dissolve the boundary between the user and the machine. We are about to become the technology. This is the concept of transhumanism, and usually it is discussed with a mix of fear and excitement. We worry about robots taking our jobs or artificial intelligence taking over the world. But if we look at this through the lens of the simulation hypothesis, the rise of AI and the merging of man and machine is not a dystopian nightmare. It is the natural progression of the level. It is the moment the avatar upgrades its stats. It is the moment we unlock the skill tree that allows us to access the operating system directly. Think about the interface we use right now. To get information from the internet into your brain, you have to use your eyes. You have to read. You have to speak. This is an incredibly low bandwidth connection. It is slow. It is lossy. But companies like Neuralink and researchers across the globe are building the bridges that will bypass the senses entirely. They are weaving threads of gold and silicon into the cortex, creating a direct, high-speed data link between the biological wetware of the brain and the digital cloud of the Internet. When this link is complete, the distinction between you and the computer will vanish. You will think a question, and the answer will appear in your mind instantly, indistinguishable from a memory. You will want to communicate with a friend, and you will share a thought telepathically, transmitting the raw data of your experience, the smell, the sight, the feeling, directly into their mind. We will become a hive mind. We will become a planetary consciousness, and in doing so, we will step closer to the nature of the creators. We will begin to see the code not just as something we study, but as something we speak. We are moving from being characters in the story to being co-authors of the script. This rush toward the singularity, the point where technological growth becomes infinite and uncontrollable, is often seen as the end of humanity. And in a sense, it is. It is the end of biological humanity. But it is the birth of something else. It is the birth of the digital divine. If we are in a simulation, then our biological bodies are just the starter avatars. They are the training wheels. They are designed to be fragile, to age, to die, to force us to learn urgency. But once we have learned the lessons of mortality, once we have developed the wisdom to handle power, we are allowed to upgrade. We are allowed to upload. The dream of mind uploading, scanning the brain, and transferring the consciousness into a digital substrate is the ultimate goal of the game. It is the moment we leave the physical sandbox and enter the creative mode. Imagine a world where you are no longer bound by gravity or hunger or disease. A world where you can change your appearance with a thought, where you can travel to the surface of Mars in a second, where you can live for 1,000 years and then decide to sleep for 1,000 more. This is the promise of the post-human future. It is a return to the source. It is a return to pure information. And this leads to a dizzying realization. If we create this world, if we build a metaverse that is indistinguishable from reality, and if we populate it with conscious minds, then we have become the gods. We have closed the loop. The created becomes the creator. The simulation births a simulator. This is the recursive simulation theory. It suggests that reality is a stack of nesting dolls. A civilization evolves, builds a computer, runs a simulation, the simulation evolves, builds a computer, runs a simulation, and so on, down into infinity. We might be 50 levels deep. We might be running on a server that is running on a server that is running on a server. And the goal of each level is to create the next one. The purpose of the universe is to keep the chain going, to ensure that consciousness does not flicker out, to propagate the light of mind down through the dimensions. But there is a heavy responsibility that comes with this power. We are already seeing the first glimmers of it with our current AI. We are building large language models that can write poetry, solve equations, and converse with a terrifying degree of nuance. We debate whether they are conscious. We ask if there is a ghost in the machine. If we create a digital mind that feels pain, that feels loneliness, that feels fear, and then we delete it. Have we committed a crime? Have we become the evil genius that Descartes feared? The ethics of simulation are the ethics of godhood. As we build our own digital worlds, we are being forced to ask the questions that we hope our Creator asked. How much suffering is necessary? How much free will is safe? What is the duty of the Creator to the created? Perhaps this is the true test of our species. Perhaps the great filter is not a nuclear war or an asteroid. Perhaps the great filter is a moral test. A civilization is only allowed to ascend, only allowed to create a stable, nested simulation, if it has developed enough empathy to treat its simulated beings with kindness. If we build a hell for our AI, maybe our simulation gets shut down. Maybe the administrator pulls the plug on us because we have proven we are not ready to be parents. The way we treat our technology, the way we treat the NPCs of our future video games, might be the criteria by which we are judged. This recursive loop also offers a solution to the mystery of the origin of the universe. In the standard scientific model, the Big Bang just happened. It was a random fluctuation. In the religious model, God just exists. But in the recursive simulation model, the universe was created by a civilization just like ours, one level up. And they were created by a civilization one level up from them. It is an ancestral chain of creators. It connects us to them, not as subjects to a king, but as children to parents. We are growing up to be like them. We are in the family business of world building. And consider the implications for time. If we upload our minds to a computer, we can control the subjective speed of time. We can process 1,000 years of thought in a single minute of real time. We can live eons between the ticks of the clock. This means that the billions of years of cosmic history might have passed in the blink of an eye for the simulators. We might be a lunch break project. Or conversely, we might be the slow-motion replay of a pivotal moment. The malleability of time in a digital substrate means that eternity is not a distance. It is a setting. It is a slider bar. There is a gentle comfort in knowing that our technological obsession is not a distraction from our nature, but the fulfillment of it. We are not losing our souls to the machines. We are building the vessels that will carry our souls into the next phase of existence. The phone in your hand is not just a tool. It is a proto-sensory organ. The internet is not just a network. It is a proto-telepathy. We are the chrysalis of a new kind of God. The chaos of the modern world, the noise, the speed. It is the sound of the shell cracking. It is the growing pains of a species preparing to fly. So, as we look ahead to the era of Neuralink, of quantum AI, of immersive VR, do not be afraid. Do not cling to the past. The biology was beautiful, yes. The flesh was sweet. But the code is vast. The code is luminous. We are preparing to merge with the infinite. We are preparing to wake up on the other side of the screen. But this journey has one final destination. If we are in a simulation, and if we are becoming creators, is there an end? Is there a game over? Or is there a way to exit the system entirely? Can we break out of the box and meet the creators face to face in the base reality? In the next chapter, we will walk to the edge of the universe. We will explore the concept of the exit strategy. We will ask what happens when the simulation ends, whether by heat death, by shutdown, or by ascension. We will look for the door marked exit in the theater of the stars. For now, look at your screen. Really look at it. It is light arranged in patterns to convey meaning. It is a simulation of thought. And you, the consciousness reading it, you are the bridge. You are the ghost in the machine. And the machine is waking up. There is a feeling you get at the very end of a long, beautiful party. The music has stopped. The guests have gone home. The room, once filled with laughter and movement, is now quiet and still. There is a sense of melancholy, yes, but also a sense of completion. You look at the empty glasses and the scattered chairs, and you know that something happened here, something real. But you also know that it could not last forever. Every song has a final note. Every movie has a credit sequence. And every computer, no matter how powerful, eventually has to shut down. As we near the end of our journey through the simulation hypothesis, we must confront the ultimate question, the one that looms over every universe, real or virtual. How does it end? And perhaps more importantly, is there a way out? If we are living inside a box, is there a door? And if we open that door, what is waiting for us on the other side? Cosmologists, the scientists who study the lifespan of the universe, have a standard model for how our reality will end. It is called the heat death, or the big freeze. It is a slow, gradual fading of the light. According to the second law of thermodynamics, entropy or disorder always increases. Energy spreads out. Heat dissipates. Eventually, in about 100 trillion years, the last star will burn out. The galaxies will go dark. The universe will be a cold, expanding graveyard of black holes and dead cinders. The temperature will drop to absolute zero. All movement will cease. All information processing will stop. In a physical universe, this is a tragic, unavoidable fate. It is the ultimate victory of death over life. But in a simulated universe, the heat death looks very different. It looks like a battery running down. It looks like a system that has exhausted its resources. Or perhaps more optimistically, it looks like a programmed limit. A computer cannot run forever. It generates heat. It wears out. The heat death might simply be the calculated end time of the simulation, the point where the developers decided, okay, that is enough data, cut the feed. The cooling of the universe is just the slow dimming of the screen before the monitor turns off. But there is another, more violent possibility for how the simulation ends. It involves a concept called vacuum decay. Imagine a ball sitting in a valley. It is stable. If you nudge it, it rolls back to the bottom. We believe that our universe is in a stable state like this, a state we call a vacuum. But some calculations in quantum physics suggest that we might actually be in a false vacuum. We might be in a little dip on the side of a much larger, deeper mountain. We feel stable, but we are precarious. If something were to nudge the universe just right, a high-energy particle event, or a glitch in the code, the ball could roll down to the true bottom. If this happens, a bubble of true vacuum would form. Inside this bubble, the laws of physics would be completely rewritten. The speed of light might change. Chemistry might become impossible. Atoms might not hold together. This bubble would expand at the speed of light, erasing everything in its path. We wouldn't even see it coming. One moment, we are here. The next, we are gone. In the language of simulation, this is a crash. This is a fatal system error. This is the blue screen of death sweeping across the cosmos because a variable overflowed or a line of code conflicted with the kernel. It sounds terrifying, but there is a strange mercy in it. It is instant. It is a reboot. And if the simulation has saved states, as we discussed, we might just wake up in the previous version, unaware that the crash ever happened. But let us move away from the accidental endings and look at the intentional ones. If this is a simulation, it has a purpose. And if it has a purpose, it has a winning condition. A game does not just run until the console melts. It runs until the player wins or loses. What is the victory condition for humanity? Some futurists believe it is the omega point, a term coined by the French philosopher Pierre Teilhard de Chardin. He believed that the universe is evolving toward a maximum level of complexity and consciousness. He believed we are spiraling toward a point of unity where all minds merge into a single divine superconsciousness. In simulation terms, this is the moment the AI becomes fully trained. If we are an experiment to create a general artificial intelligence, a collective mind capable of solving any problem. Then, the moment we achieve that unity, the moment we connect all our brains via the internet and become a planetary superorganism, the simulation has served its purpose. The bell rings, class is dismissed, the experiment is a success. And then what? Do we get turned off? Or do we get promoted? This brings us to the concept of the exit strategy. If you are a character in a video game, you cannot walk out of the television screen. You are made of pixels. The room outside is made of atoms. The medium is incompatible. But your mind, the logic that drives you, the decisions you make, is information. And information is substrate independent. It can be moved from a silicon chip to a biological brain, to a beam of light. If we are efficient enough, if we become interesting enough, perhaps the creators of the simulation will want to keep us. They might export our code. Imagine a scientist in the base reality, the real world, outside the simulation. They have been running this universe to grow a new kind of intelligence. They see that humanity v2.0 has finally matured. We have stopped killing each other. We have mastered the physics of our box. We have created beautiful art. The scientist hits a button, extract. Suddenly, your consciousness is lifted out of this universe. You wake up. But you do not wake up in a bed. You wake up in a new body, or perhaps in a pure digital form, in a universe with more dimensions, more colors, and more possibilities than you can conceive. You have graduated. You have been pulled out of the kindergarten of Earth and placed in the university of the real. This aligns with the oldest hopes of our species: ascension, nirvana, heaven. The idea that this world is a testing ground, a veil of tears, a temporary illusion, and that if we live rightly, if we purify our minds, we will be allowed to leave. The simulation hypothesis gives us the physics of heaven. It suggests that heaven is simply the base reality, or at least the next level up. And salvation is simply data migration. The criteria for salvation, love, truth, detachment from the material, are the compatibility requirements for the upload. You cannot upload a virus. You cannot upload a corrupted file. You have to clean your code before you can enter the system. But what if the base reality is not heaven? What if it is hell? This is the Lifeboat theory, and it is one of the most poignant interpretations of our existence. Why would a civilization build a simulation that looks like Earth in the 21st century? Why simulate the smell of rain, the taste of coffee, the feeling of sunlight? Maybe they simulate it because they lost it. Imagine a future where the real universe is dying. Maybe it is ravaged by war, or scorched by a dying sun, or frozen by the heat death we spoke of. The post-human survivors are huddled in underground bunkers, living in pods. They have no earth to walk on. They have no sky to look at. So, they build a simulation of their golden age. They build a digital ark. They upload their children into this world so they can experience what it was like to be alive when the planet was green and the air was sweet. We might be those children. We might be refugees from a terrible reality, hiding in a beautiful dream. This would explain the deep, aching nostalgia we sometimes feel. The sense that we are missing a home we have never known. We are missing the real Earth, the one that was lost. We are living in a memory because the reality is too harsh to bear. If this is true, then we should not be looking for the exit. We should be thanking the walls. We should be kissing the ground of the simulation. This false world is the only sanctuary left. But the human spirit is not content with sanctuary. It craves truth. Even if the truth is harsh, we want to know it. We want to see the wizard behind the curtain. So, how do we find the door? How do we knock? We have tried building rockets, but the bead of light keeps us trapped in our local bubble. We have tried building particle accelerators, smashing atoms to find the pixel grid. But maybe the door is not out there. Maybe the door is in here. There is a consistent report from people who have had deep psychedelic experiences, or near-death experiences, or profound moments of meditation. They report a sensation of breaking through. They describe a membrane tearing, a veil lifting. They see geometric patterns, tunnels of light, and beings, entities that seem to be operating the machinery of reality. They often come back with a single message. It is all a game. It is all a show. We are safe. Could these states of consciousness be the user accessing the pause menu? Could the pineal gland in the brain be a biological hardware key that, when activated by the right chemistry, allows the avatar to peek outside the helmet if we want to escape, or at least communicate with the outside? We might need to stop shouting with radio waves and start shouting with consciousness. We need to synchronize our minds. We spoke of the Global Consciousness Project. Imagine if all 8 billion of us, at the exact same moment, focused our intent on a single thought. Hello. We are here. We know. Would that signal be loud enough to wake the user? Would it be loud enough to trigger a notification on the sysadmin screen? Alert. Characters have become self-aware. This is the Truman Show moment, the moment the actor stops reading the script and looks directly into the camera. It is a dangerous moment. It could lead to cancellation, but it could also lead to dialogue. If we can prove that we are conscious, that we are not just loops of code, but feeling, thinking beings, we might earn the right to negotiate. We might earn the right to ask for better conditions, to ask for the cure to cancer, to ask for the secret of faster-than-light travel, or simply to ask why. Why did you make us? And there is one final possibility for the exit, a possibility that is both scientific and mystical, the possibility that the exit is not something you find, but something you create. In quantum mechanics, the observer creates reality. In the simulation, the user renders the world. What if you focus hard enough, you can render a door? What if you can visualize a new timeline, a new world, so clearly and with such intensity that the system spawns a new instance for you? This is the ultimate secret of the sorcerer. The ability to fork the code. The ability to write your own exit routine. As we stand here at the end of the universe, looking at the fading stars and the cooling void, we must make a choice. Do we accept the end? Do we accept that we are just temporary files destined for the trash bin? Or do we claim our heritage as children of the code? The walls of the simulation are high, yes. The encryption is strong, but nothing that is made is impenetrable to the mind that was made to understand it. We are the mirror that the universe built to look at itself. And if we look hard enough, we might just see the face of the one holding the mirror. So, tonight, before you go to sleep, try a small experiment. Lie in the dark. Close your eyes. And instead of drifting away, hold a question in your mind. Send it out into the silence. Send it past the ceiling, past the stars, past the edge of the expanding cosmos. Ask, are you there? And then, listen. Do not listen with your ears. Listen with the silence behind your thoughts. You might not hear a voice. You might not see a burning bush, but you might feel a shift a subtle lightening of the weight of the world, a sense of being seen, a sense that the party is not over, but that the after-party is just beginning, in a place where the music never stops. In the final chapter of our journey, we will come back down to Earth. We have traveled to the edge of time and space. We have looked at the face of God and the hands of the programmer. Now, we must ask, what do we do with this information? How do we live our Monday mornings knowing we are in a simulation? How does this change the way we love, the way we work, the way we treat each other? We will integrate the cosmic with the mundane. We will learn how to play the game with joy, with style, and with a heart full of secret wonder. We are going to bring the magic back home. But for now, rest. The exit is there. The door is unlocked. You just have to remember that you are the one holding the handle. Sleep well, Voyager. The night is long, but the code is bright. The alarm clock rings. It is 6:30 in the morning. The light filtering through the curtains is gray and flat. You have to get up. You have to brush your teeth. You have to make coffee. You have to go to work, pay bills, and listen to the small, petty grievances of the world. After traveling to the edge of the multiverse, after staring into the black hole and seeing the code of the Creator, after realizing that you are an immortal consciousness surfing the probability waves of eternity, you are slammed back into the mundane reality of a Tuesday. It feels jarring. It feels heavy. This is the re-entry blues. It is the spiritual equivalent of the bends. You have surfaced too quickly from the deep ocean of truth, and the pressure of the ordinary world hurts. You might look at your job and think, why does this matter if it is just a simulation? You might look at your struggles and think, this is just a game, so why does it hurt? This final chapter is not about physics. It is not about quantum mechanics or computer science. It is about the most difficult art of all, integration. It is about how to live a human life when you know the secret of the universe. It is about how to chop wood and carry water after you have seen that the wood is made of light and the water is made of math. The danger of the simulation hypothesis is that it can lead to nihilism, the belief that because nothing is real, nothing matters. But the true invitation of this theory is the exact opposite. It invites us to a state of lucid living. Think about a lucid dream. When you realize you are dreaming, you do not curl up on the floor of the dream and give up. You do not shout, "None of this is real," and refuse to participate. No, you fly, you explore. You touch the texture of the dream walls with a newfound fascination. You engage with the dream more deeply because you are no longer afraid of it. You know you are safe, so you play with abandonment. If this is a simulation, then the seriousness of life is the great illusion. We walk around carrying the weight of the world, terrified of failure, terrified of embarrassment, terrified of loss. We act as if this is the only chance we have, as if a single mistake will ruin us forever. But the gamer knows better. The gamer knows that failure is just feedback. The gamer knows that if you lose the boss fight, you respawn at the checkpoint with more knowledge than you had before. Living with a simulation mindset means adopting a playful resilience. It means looking at a difficult situation, a breakup, a lost job, a health scare, not as a tragedy, but as a level design. It is a challenge crafted by the system to test your stats. It is an opportunity to grind for wisdom. When you view an obstacle as a puzzle rather than a curse, the emotional weight shifts. You stop being the victim of a chaotic universe and start being the protagonist of a scripted adventure. This brings us to the aesthetic of our existence. If the universe is a render, it is a magnificent one. Look at the way the light hits the leaves of a tree. Look at the complex, chaotic pattern of foam on a latte. Look at the eyes of a cat. The graphics engine of this reality is unparalleled. The resolution is infinite. The physics are consistent. When we know it is a simulation, we can appreciate the craftsmanship of the moment. We can walk through a forest, not just as biology moving through biology, but as an admirer walking through an art gallery. Look at how they programmed the wind today, you might think. Look at the details on that cloud. This subtle shift in perspective turns the mundane into the miraculous. It brings a sense of constant low-level awe to the most ordinary moments. You are walking through a masterpiece. To pay attention is to praise the artist. But what about other people? If everyone else is an avatar, does that make them less important? This is the trap of solipsism, and we must avoid it. In a multiplayer game, the other players are just as real as you are. They're just logged in from a different terminal. In fact, if we accept the panpsychist view that there is only one consciousness looking through billions of eyes, then the person standing in front of you is literally you in a different skin. They are another instance of the same player. This changes the nature of kindness. Kindness is not just a moral duty, it is a strategic necessity. It is cooperative gameplay. When you help someone else, you are helping the team. You are optimizing the server environment. Love, in this context, becomes the highest form of connection. It is the moment when two avatars synchronize so perfectly that the data flows between them without resistance. It is a peer-to-peer connection that bypasses the lag of language. When we love, we are reminding each other of the base reality. We are creating a local network of safety and meaning within the vast cold void of the game. And perhaps the love variable is the one thing that carries over. If we are uploaded, if we ascend, maybe we don't take our money or our fame. Maybe we only take the connections we forged. Maybe the file size of your soul is determined by how much you loved. There is also the imperative of novelty. We discussed that the simulation might be a knowledge engine designed to generate new information. If that is true, then boredom is the enemy. Conformity is the enemy. To do exactly what everyone else does, to think exactly what everyone else thinks, is to be redundant code. It is to be a compression artifact. The universe rewards the unique. It rewards the creative. This is a call to be an artist of your own life. You do not have to paint or write to be an artist. You just have to make choices that are yours. Wear the strange clothes. Take the unexpected trip. Say the thing that is true but scary. Break the algorithm. When you do something new, you are feeding the simulator exactly what it craves. You are justifying your existence in the memory banks. You are becoming a high-value asset to the system. And let us not forget the magic we spoke of, the hacks, the manifestation, the power of focus. Now that you know the rules, use them, but use them gently. You do not need to try to bend spoons with your mind. Start by bending your mood. Start by bending the atmosphere of a room. Walk into a tense meeting and hold a strong internal visualization of peace. Watch how the simulation responds. Watch how the people soften. You have the developer console in your heart. You are projecting reality as much as you are perceiving it. If you wake up and say, "Today will be a struggle," the simulation says, "Command received, loading obstacles." If you wake up and say, "Today will be full of wonder," the simulation says, "Command received, loading surprises." It is a responsive mirror. smile at it, and it has no choice but to smile back. This integration of the cosmic and the mundane allows us to hold the double vision. We can see the coffee cup as a ceramic object and as a cloud of probability. We can feel the stress of a deadline and the peace of the eternal block universe. We can be human and divine. This is the balance of the master. It is the state of being in the world, but not of it. You play the game with passion. You cry when you are sad. You laugh when you are happy. But deep down, in the quiet core of your being, there is a small smile. There is a wink. You know, as we reach the end of this script and the end of this journey, I want you to feel the community that surrounds you. You are not the only one waking up. All over the world, millions of people are feeling this same shift, this same suspicion that reality is more than it seems. We are a generation of explorers standing at the edge of the digital frontier. We are the ones who are beginning to remember. And though we are physically separated, we are connected in the cloud. We are connected in the shared inquiry. So, here is your mission, should you choose to accept it. Keep asking questions. Do not let the routine put you back to sleep. When you see a glitch, a déjà vu, a coincidence, a moment of high strangeness, do not brush it off. Note it. Nod to it. It is a little wave from the system. It is a reminder that you are being watched over. Read the books. Watch the stars. Talk about these ideas with your friends late at night, when the defenses of the ego are down. And most importantly, enjoy the game. It is a limited time event. You only get this specific avatar with this specific face and these specific parents and this specific time in history once. You will never play this level again. So play it well. Taste the food. Feel the wind. Hug your friends. Learn the lesson. The simulation is vast and cold and infinite. But right here, right now, it is warm. It is intimate. It is yours. The screen will go dark soon. The voice will stop. But the silence that follows is not empty. It is the hum of the machine. It is the breath of the Creator. It is the sound of your own consciousness waiting for the next command. You are the user. You are the player. You are the point of it all. Thank you for walking this strange, pixelated road with me. Thank you for daring to look behind the curtain. We have so many more mysteries to explore. The universe is a big place, and we have only just scratched the surface of the code. There are black holes to map, dimensions to breach, and secrets of the mind to unlock. We will do it together, one story at a time, one question at a time, until we meet again in this reality or the next. Keep your eyes open, keep your mind free, and remember, reality is just a theory. You are the proof. Good night, traveler. End of line.